Okay, can I have everyone's attention, please? If you all take your seats, we'll get this show on the road. We have a very, very full program today. I think we have just over 30 speakers. Crammed into the hours between 9 and 5 with minimal coffee breaks, so we have private coffee breaks and lunch. We have very, very short presentations because there's an awful lot going on that we want to cover. So, we're going to start on the dot, 9 o'clock. And yeah, welcome to our workshop on launching CubeSats from Australia. This workshop is hosted by University of New South Wales, and in particular the Australian Centre for Space and Science Research. And the motivation for this workshop is that we're trying to touch on the topic of new space and the opportunities that new space offer Australia. So new space is a growing philosophy. It's all about low-cost access to space and low-cost platforms in space. And this is a perfect opportunity that Australia can buy into without any previous space heritage or without significant space heritage in space industry. There are significant events happening already in Australia, and these will be covered in some of the presentations. And there are significant opportunities coming up in the future. So we'll be looking at aspects of the space industry, everything from how to procure launch, how launch is regulated in Australia, what types of support systems exist to Australian satellite builders or space industry projects, and what is going on at the moment. Ideally, what we're trying to do is we're trying to identify the opportunities and the challenges that exist for us to carry out space projects here in Australia. So bear that in mind when it comes to watching the presentations and asking questions. So as I said, we have a rather full program. You should have been handed a program as you came in. If you don't have a program, there is one available outside. And it is probably broken up into categories. So we have launch procurement, launch sites, the legal side of things, what launch technology is up and coming. Then we have a list of CubeSat missions which are happening, which have a significant involvement in Australia. And then what existing mission support technologies or services exist within Australia. Most importantly, we have scheduled morning tea at 10:20. We grab coffees, juices, and so on. We'll have another scheduled break around about 12 o'clock. Lunch is at 1:25, and we have our community at 3:25. We close at 5 o'clock, and then we're all going to, well, as many of us as can, will retire to the White House for beer, pizza, and networking, in that order. As always, there's some important housekeeping. In the case of an emergency, if you want to be joining on the spot, 5 to report fires, terrorist events, etc. If there is a fire alarm, it will be a continuous alarm, and there will be a PA transmission requesting everyone to evacuate. The evacuation is proceed left and out to the green, where you gather there. In the case of needing to go to the toilet, then right, and down the end of the hallway there are toilets. And a few reminders. Speakers who have not given us slides or need to update slides, please do that in the breaks. We are going to be very, very tight on time, so we're going to be very, very strict. Speakers will get a 2-minute warning on a bell. Again, can we have a demonstration with the bell? Okay. And then a final warning, which will be the same alarm, and I will get up and cut you off at that point. If you run out of time, we'll have questions, which would be fantastic, because that would be good. Questions will be directed firstly to the webcast participants, so this is being simultaneously webcast, and there are people tuning in from around the world, and then we'll be thrown open to the audience. If you don't get the opportunity to ask a question, please, by all means, grab the speaker and question in the break, and pass it on asking questions. If there's any problems, please see either June is here, Sanad has disappeared, but Cheryl is around. We've met Cheryl, myself, or anyone who's up here at the front. Okay. On that note, I will invite the first speaker up, who is Professor Andrew Dempster from the Australian Centre for Space Engineering Research, who will talk a little bit about the context of new space and where we sit within UNSW. Andrew?
Okay, yes, I'd like to welcome you to UNSW today in this event. Welcome to extended also to the people who are listening to us streaming in New Zealand, Canberra, Adelaide, and other places that we don't know about. This is, I think, quite an important topic for a number of reasons that I hope I'll make clear during my presentation. The first is that the standard university font has not worked out on this computer, actually, because UNSW joined up. Okay, Space 2.0 new space. So what is it? It's probably the most exciting thing that's happening in space at the moment. We're moving away from agencies, moving towards low-cost access to space, use of some commercial components in space, and providing integration services. I'm not going to spend a lot of time on this because the second speaker, Tim Parsons, will cover it in more detail, but I will just introduce it a little bit. CubeSats are almost the very definition of a disruptive technology. Clayton Christensen, who wrote The Innovator's Dilemma, he's paraphrased in that first quote there. A market that couldn't previously be served, so you're going to have a new market disruption, or a solution that's cheaper and more convenient than what's existing, so a low-end disruption. Now, both of those types of disruption apply to CubeSats. The second point there is that the CubeSat brings a new package of performance attributes that initially are not useful, or that are not perceived as useful to the customer, but the improvement in those performance characteristics means that the disruptive technology can take over from the existing technology. So the time to get into CubeSats is now, because it's really going to be a big thing. Now, I have advocated for some time that we should be modelling a space agency in Australia or the UK, and this UK catapult, space catapult there, is also a fantastic initiative which we should almost copy exactly, and it would be a fantastic initiative for Australia. They did a study last year, nearly 4 foot small is the new big, and they produced a number of statistics, which I imagine Tim's also going to refer to. And there's a couple there from 2 studies. One was done in the US, and this one was done in the UK, where they're talking really big numbers. We're talking about the next 5 to 10 years of where the market is going to be. For CubeSats, you can see for that first number, 1.9 billion by 2019 is the entire nanosatellite, microsatellite market. Obviously, CubeSats are the nano part of that. And similarly, for Earth observation only, the British study was saying that there's going to be a £260 million market there in that same sort of time frame, 2020. So, some quite big numbers. There's 1,000 CubeSats due to be launched in the next 5 years, and the numbers in terms of business are quite large. Now, I've been running the centre now for 4 or 5 years, and during that time I've been collecting news articles about countries other than Australia who are doing good things in space. This slide goes on for some time. Now, there are 70 countries in the world that have space agencies. Australia is not one of them. In fact, Australia is the largest economy in the world not to have a space agency. Of the OECD countries, the only other ones that don't have a space agency are New Zealand and Iceland. Sorry to our friends who are listening in New Zealand, but you're as bad out as we are. So, what are we going to do about it? What are we going to do about it? Do we look to the government for policy? There's a PDF of the satellite utilization policy, which is, as far as I'm concerned, United Space Law policy. I searched it there, the word CubeSat doesn't appear. I've got a quote here for, the biggest thing that's happening in space is this Space 2.0, and there is the reference in the satellite utilization policy to anything to do with current activity in new space. I'll give you a bit of time to absorb that. Now, when the draft of this policy came out, I just dug up my response to it the other day. Some of these words are from the last Abertanians as well, but that's some of the words that I used to describe the draft. The policy, the wording did not change in this area. So it's based on 20th century assumptions. Small satellites of CubeSat standard have put space within the reach of educational institutions, of course. Academia, not mentioned. Industry, more or less, not mentioned. So as far as a not useful document goes, I commend this one to you. On satellites and launch, the wording goes, the Australian government does not see an Australian satellite manufacturing or launch capability as an essential element of its approach to assured access to critical space and analytical services. Again, my response there is underneath is, get out of the way. Right? I mean, so the government has failed, right? The people who have advised and lobbied the government have failed. Or you can think that the people who have lobbied and advised the government have succeeded in preventing Australia approaching a commercial space industry. We don't have a space policy, we don't have a space agency, we don't have a space program. So, you've all seen this, and you think that that's a bad message, right? Australia is hopeless, but forget the failure of the nation. Look at the success of the drink company. This is where we need to be thinking, right? The government is not going to lead us on this. The government needs to be led. So, how are we going to do it? It's going to have to be led commercially. So this is where we're thinking at the moment. Particularly, I am preceding Tim Parsons, who will come up and talk about some of the more commercial aspects, and we'll talk later about Delta B, an initiative that we're driving here in Sydney. There are other programs. The STO have some programs, and there are science programs, which we will hear about later today. But for us, the emphasis really is on this commercial side. There are some pretty hard heads, or some opinions that need to be changed here. And I was trying to come up with a slogan, some sort of way of thinking that changes the way people perceive space. This whole Space 2.0 is about making money, right? Google did not invest $1 billion in SpaceX for fun, because it was a good thing to do. It's all about money. Now, this is the sort of idea I'm trying to push, but I think for this government, we need a 3-word slogan, and so I think maybe that's just where we need to be focusing. Even this week, I've been pushing this idea that the UK Space Agency is the best model for us. Even this week, they announced 7 programs, including CubeSats to e-finance, benefits emerging economics. It's all about money. Just one thing to think about for today, a question you might want to keep in mind, is again in the UK, they've set up this UK CubeSat forum where the people in the UK who communicate with each other and keep in touch regarding CubeSats. And as Barnaby's slide pointed out, we're trying to put together a CubeSat directory for everyone who's in Australia and New Zealand who's interested in CubeSats. Please either go to that link. It looks like that. There's a new button that's just gone up this morning on the AXA webpage so that you can gather your information to talk about CubeSats. Yeah. So I've got in before I'm trying to reclaim some of that time that Barnaby used. I'll pass it straight over to Tim. Yeah. This is Tim Parsons.
It's Harry. Right, you can do this. Terrific, thank you. Okay, so I'm going to be really quick. I can see a lot of familiar faces in the audience, so people we've been talking about. So quite a few of you here know a little bit about our plans. So in a way, this is a very quick update. For folks who are watching remotely, we are starting a program of accelerating practical commercial space in Australia. Exactly what Andrew just mentioned, not only showing the leadership in setting up this workshop and making sure it's streamed live, but also in proving the point that we have to show leadership to government. We have to really show them that there is a policy area for them to tackle. So the key message that we have with Delta V is we want to accelerate things commercially. And in that sense, we're actually doing what every other industry in the world is currently trying to do now, which is trying to catch up with the tech industry, catch up with the next generation that are coming through. A core message that I think has really resonated for me from another couple of industries, logistics and finance. The space industry is broken. It is fundamentally broken. The careers that we should be seeing, the activities that we should be seeing worldwide are not happening. And one can even argue that in North America now, that there's a very strong belief that their space industry is broken and they need to reform it. So in some ways we're ahead, because at least we kind of don't have one yet. But essentially, if you look at the big space companies currently in the industry, they're slow-moving behemoths. People don't really love working in those companies and tend to leave them and join drone companies and search engine marketing companies and companies doing entrepreneurial stuff. That doesn't seem to be what space is about. Entrepreneurs, they look at space, they look at this traditional view of space, and certainly the conversations I've had, and first of all, you must be crazy. Why would you do anything in this ridiculous industry where you're doomed to failure right from the get-go? It's too hard, it's too big, there's too many barriers. And then I think for everybody else out in the society, I've had so many conversations where I say, oh yeah, I'm doing a startup. I've got several universities involved, and we're working on Space 2.0. And they put their head down for a second, they look at me and say, you mean architecture? Or like using buildings better? I say, no, space. And then their eyes just sort of start rolling, and they absolutely think I'm on drugs. So it's actually an area that people don't relate to. They think it's pie in the sky. They think it's sort of crazy talk. So these are the things that prove to me that the space industry is broken. Now, if you compare it to the tech industry has the world's richest company in it. It's not Morgan Stanley, it's not Citibank, it's not BHP, it's Apple Computer. They have probably $250 billion in cash in the bank. They have more money right now than any other industry. The little thing that you have in your pocket right now is an absolute dynamo worth more than building dams, worth more than building aircraft carriers. worth more than shooting rockets into space. So we had to learn what was it that took us from an industry of massive mainframe computers locked in buildings inside universities and banks, where it was inaccessible, exotic, and kind of a broken industry, and we're talking about the 60s and 70s, to where we are today, where it's the fastest moving cultural and technological area in the world. My belief is that small satellites are the answer. They change the political dynamic. They accelerate the innovation. We get to attach ourselves to Moore's law the exact same way the computer science industry has, the software and hardware industries. And we're seeing that the cost of receiving and using the products of our industry, specifically data, as well as the occasional space tourism endeavor, but specifically data, the cost of that has dropped by probably a millionfold. If you wind back 10 years, to do the kinds of things you can do with a $50 Amazon server now, you would need to be in Sandia National Laboratory. So the sort of things that we can do with data and vast quantities of data commercially for low cost means that the buy-side economics have fundamentally changed. Small satellites are about changing the supply-side economics, and that's really how you spark a revolution. Many of you might have seen this before. The analogy is, on the left-hand side of that picture, we have the mainframes of the 1970s. Gigantic spacecraft, big as a bus, cost hundreds of millions of dollars to launch, take years and years and years to engineer, have to be perfect, cannot afford to fail, everything as frigid and locked down, and as waterfall project managed as you can imagine. And on the far right-hand side, you have essentially a disposable spacecraft. Yes, we do want to deal with them successfully and aggressively, but a disposable spacecraft that's worth a fraction of the commercial value that it's delivering. This is the same graph Andrew put up. We're seeing that, yes, there is a big spike in the number of vehicles that are proposed in the next few years. We also see an opportunity in that there must be an even bigger graph of the number of people who want to put payloads and business models into space, and we want to access them. We're seeing, even in the first month of this year, we had something like $4 billion of new investment announced specifically in the small satellite area. That's the Google, SpaceX, Fidelity Investments announcement and the Virgin Qualcomm announcement. And of course, previous to January, we had at least $500+ million in deals and investment, and it's all private money. So a little bit about Delta V. We are an industry, academic alliance, startups, and scrappy university groups that have come together. We have two entities in our group. We have a space missions and data company. We have a space accelerator program, and we have, underneath both of those, we have a CubeSat-based platform, a vehicle platform, to fly payloads into space. The idea is not to compete, it's to collaborate. If you want to do exactly what we're doing, we want to talk to you and join forces, because we have to set that example. The founders at the bottom, Sabre Astronautics, Australian Centre for Space Engineering Research through UNSW, the University of Sydney Space Net Group, and LaunchFox, a group of let's make it happen, let's just stop trying to pitch governments and pitch people and get on with it group. And essentially, we see the chance to do a Pacific-wide accelerator program too. I've got colleagues in Seattle and in Los Angeles who have grabbed hold of this model and say it's the best thing they've ever seen. Can we get one of these please where we are? We have talent right across the region. We have governments like Singapore who put serious money into drones and other areas of innovation. So let's get happening, let's get talking to all the talent in this region and get ourselves into space. I think the key thing is that this is a tipping point moment. This is an X-Core Lynx. They're probably going to fly this to very high altitude, very high speed this year, and maybe up into space even before the end of the year. And this is the kind of disruption that's on its way. We need to be ready for that kind of world, and we need to be ready to fly these out of Australia. Thanks.
We've got time for a couple of questions if you would like. Well, that was completely clear. Yes.
Hi.
You mentioned private money. how big a driver is that going to be for us in the initial phases until we get space engines?
Huge driver. I believe that if I'm seeing from the drone industry and some of the other hardware-based industries, there is an appetite from investors, and in fact there's an increasing sophistication of investors that they better get on board now, otherwise they're going to miss out on the 10x. And specific investors, I'm thinking about angel investors. Angel investors are starting to get wise, they're starting to realise that they're partnering with people in the United States and in the UK. I'm a member of the Space Angels Network, which is a worldwide network of early-stage space investors, and we're seeing more and more deals. And as we see these deals, we're getting smarter and smarter. So I think the timing is really great. And I think also if government sees that private angel funding and private equity money is coming into an area, then they've hit a proof point for them. Okay, this is real. And this is not just people saying, give me money so I can play with stuff. State government's also been very supportive. But again, all the funding that we're seeing in Australia right now in this area are in the form of matching funds. So, in a way, that's good. That shows that we've got to do our engagement with society and with business and get that right.
Okay. Thank you very much.
Thank you.
Our next speaker comes in from the UK and is going to be presenting remotely and live. It's Craig Clark from Clark Space, and he'll be presenting on infrastructure development, specifically developed by Clark Space for CubeSats. Okay.
Okay, hello everyone, and thanks for having me at the AXA CubeSats 4 and from Australia workshop today. I can't make it there in person. It's always a shame to present via internet, but I suppose it's great to still have the opportunity to communicate with you this morning. Now, I put together this presentation and tried to really need to focus on the Australian theme and to try and kind of hopefully say something that will be quite interesting to you. In order to do that, I have to say a little bit about time, space, and where we are and what we are doing. So please bear with me. I hope that it doesn't come across as a kind of naked promotion of what we're doing, but I really hope that there are a lot of areas for collaboration, and there seems to be opportunities around every corner within the CubeSat and satellite industry at the moment. And I think that with a little bit of focus and direction, I'm sure that we can look towards some hopefully quite interesting UK and Australian collaborations. So without too much further ado, I'll jump right into it now. So just to summarise time, space and what we are, we've been around for about 10 years now, and have been evangelising about CubeSats ever since we were formed. And one of the first things we ever did was create an off-the-shelf power system for CubeSats, and we've since gone on to provide lots of different subsystems, not just CubeSat subsystems, but all kinds of things, mainly within spacecraft power systems domain, to customers all over the world, and some of the bigger ones are listed there. We think that about 40% of CubeSat missions fly equipment, but those numbers are changing all the time. The market is really moving so quickly that it's quite difficult to keep up, even though that's my job. So here's a very brief structural overview of our company, just so you can see that, that we are predominantly an engineering company. Most of our staff are engineers. We don't tend to dabble in services. We've made a strategic decision that Space are not a services company, although you'll hear people tell you that's where all the money is. That's not our business, it's not what we do. We focus on building hardware and leave all the kind of bright ideas around applications and services to other people. That said, we also recognise that as one of the first movers into the market, we've always been quite close to infrastructural development of CubeSat systems. And I'll say a little bit more about that. Should it be of interest to you guys at the moment. So in order to tell that story, I first have to say a little about UCube-1, which was the first satellite to be commissioned by the UK Space Agency back in, I think it was around 2009. The satellite was actually commissioned. Now, people in the UK have been crying out for this to happen, and there was a real kind of frustration, a lack of direction in the UK, watched on in envy as the USA and Japan launched or funded and developed mission after mission based around the kind of new back then CubeSat form factor. And eventually we managed to talk the UK Space Agency into developing our own mission. Now it turns out that as ever, with budgets being very tight, the platform went on to fund 6 different payload technologies, and that just tells you something about the kind of appetite there was for this. I think around 25, I think the exact number was 24 different payloads were proposed for UCube-1, but only 6 were allowed to be selected, and actually integrating 6 CubeSat platforms into a 3-year structure is actually quite a challenge in itself. But anyway, that did enable us to develop a real kind of systematic approach to payload integration, and enabled us to develop rapid integration tools. So an interface emulator, which has now gone on and evolved into this nanobed concept, and this is really a kind of rapid development lab, almost a CDF facility for CubeSat mission analysis and development within a kind of hardware-in-the-loop framework. It's based on genetic algorithm technology and enables, as I say, optimization of different CubeSat space segments from several platforms to constellation missions. It's something that we've been about 6 years in development now, and we now have 2 PhDs at Strathclyde University finalising all of the software within this nanobed. As you can see, it's in some ways it resembles a kind of mini business unit in itself almost. You have various different areas from hardware development and mission technologies, which is essentially payload development areas, an interface to an operations center to enable real-time telemetry, payload, data analysis for operational CubeSats as well. The image here on the right with the 2 little Arduinos, that shows the very first interface emulator. I've got a slightly more advanced version of that, but anyway, I think that the nanobed concept hopefully is quite interesting. Here we see some of the output from the nanobed software, which shows you, or at least the image at the bottom shows optimized solar panel configurations. And we see this as being something that we can use to optimize any CubeSat mission with a given set of payload interface requirements and target mission ephemeris and Keplerian elements and so on. So we're now developing a network of these. There are so far 3 in development within the UK alone. We have one at the Astronomy Technology Centre, which will focus on imaging systems and other sensors, partially funded by the Environmental Committee of the UK and also the Ministry of Defence. Then we have the Scottish Centre for Excellence in Satellite Applications, which will focus on biological payloads and also secure communications, focusing mainly actually on quantum technologies, together with partners in Singapore. the satellite applications Catapult have developed an open source nanobed together with us, which is really a kind of, it's not quite free to use, there's a nominal fee to use it, but it's something that the stakeholder community in the UK can use. I know that, for example, Oxford University are using it at the moment to develop their own CubeSat mission, and I think some others drop in now and then to have a go at developing their own payloads. So it's become a really useful tool in promoting space and access to hands-on hardware and demonstrations. Oh, sorry, I'm taking a bit long here. But we're also developing nanobids with other partner countries. We have some users in the USA, South Africa, and Mexico, and these are going to enable us to kind of integrate CubeSat missions across borders, essentially. So I think it could be interesting to have a discussion about if there were any interested parties, how we could do that in Australia as well, and make this together. I know that there are plans to develop a spaceport facility in Australia at the moment, and we're embarking on that journey in the UK as well. And Prestwick Spaceport is one of the front runners to host that. We are participating in that process together with Prestwick to define exactly what we need of that as a kind of nano-satellite provider and supplier. Now, as I mentioned previously, we've always had a kind of focus on constellation development. It's always been a kind of fundamental part of our strategy. We've recognised from quite early days that that's where the nano-satellite market would end up. Of course, that's where the real consoles lay. So we've spent quite significant time and effort in developing hardware tools to enable more advanced constellations, and of course that began with the plasma thruster, which is now quite ready after about seemingly endless development. It's actually taken us 8 years to get this thing flight worthy. It's due to be launched over the next couple of months, so we're all looking forward to that. We also have developed a deorbit sail, and this is now mandatory. I understand that ESA are now going to make these mandatory, so that's something else that we've kind of spent quite a lot of time developing together with local stakeholders. We're very interested in finding new technologies, so if there are any developers out there, and we're in discussions with the BIARA GPS team for a while. We'd love to help commercialise some of these, so that's another area that we could explore together. Let's just run on. Now, flight space is growing very rapidly together with the rest of the market, and we've actually moved to much larger premises, which are in at the moment. Over the next 18 months, we'll be building integrating 33 different CubeSat platforms in our facilities. We'll be co-developing or co-integrating the Spire global platforms together with some others which will quickly run for here. We're working with the NASA team to develop the micro CWEX spectrum color monitoring sensor to develop some hyperspectral CubeSat platforms. Interestingly, I know that the Moore's law was mentioned in the previous presentation. I had it on good authority that the last time that Gordon Moore signed off in his professional life was an agreement to fund this CubeSat constellation. So I think this is probably as close as you get to Moore's law in space. Moore's open anyway. We're also developing another hyperspectral platform together with ESA called Picasso, which has very demanding payload pointing accuracy requirements and also extremely demanding payload imagery processing requirements. That's probably the biggest challenge there, somehow dealing with the immense deteriorating. I think my time's almost up. But just to move on quite quickly, we've started dabbling with telecoms platforms as well as part of the recent TNET project. Thank you. And we're very interested to see if we can actually develop CubeSat platforms that can perform usable, commercially viable telecom services for the world. This is something we're also researching under a subcontract as well. So we'd be very interested to find partners who are interested in engaging with us and helping us along that journey. So just to summarise very quickly, at least I think the obvious potential collaborative areas between flight space and Australian stakeholders might be around areas of an international language collaboration. We already have projects in place in America, Mexico, South Africa, and a network of different institutions within the UK. We'd love to invite an Australian partner on board with that. I think the alignment with spaceport infrastructure is a very interesting topic in itself. And I know that the UK Space Agency are working very closely with American stakeholders to ensure that our own national developments in that area can be mutually beneficial and create a mutually advantageous infrastructure. Now, I'm sure that these will align with Australian efforts as well, but hopefully we can perhaps do some work to ensure that they do as early as possible. And then, of course, traditionally on platform and subsystem development, we're very interested in potentially working with some Australian partners to provide a route to the global market, and I hope that might be of interest. I'm sure there's other areas we could work together too. Thank you very much.
Thank you to Robin. I must apologise to Robin. He's presenting quite amazing, like I said previously, great part. So yeah, thank you for Robin for staying up in the UK and presenting to us today. Our next presentation is being prepared by ISIS, the Innovation Solutions and Space Company out in the Netherlands, and is presented by Michelle Goldberg. Yeah, not that ISIS. And yes.
Good morning, Sydney. Good morning, attendees and our workshop in Sydney. My name is Jeroen de Boons. I'm the Launch Mission Manager for Innovative Space Logistics, a daughter company of ISIS Navigation Space, which is located in Delft, Netherlands. Personally, I would like to start with thanking the organizing committee for extending this invitation. It's an honor to give this presentation, which I am not only doing this way in such a non-interactive way, so I hope you will bear with. I have the presentation in considerations on launching satellites, for the reason that the organizing committee asked me to share thoughts and know-how that we as a company have gained through the previous experience with launch missions. To start off, I would like to start off with a quick company overview, which is found on slide number 2. The company started as a spin-off project in 2006. We currently have offices in Delft, where headquarters is. We have another location in Norway, in the ESA incubator aspect, and finally, there is currently a location in South Africa. Currently, we employ more than 50 people, and we have our own AIV facilities, not only in-house but also close by. So, the company exists on a mother company, also named ISIS, on which there are 4 daughter companies. I will focus in this presentation on the ISL, Conductive Space Logistics company. My colleague will address the other companies. If we go to slide 3, ISL is working on the launch services side of the whole business. As you can see, we are the intermediate between the satellite developers and the launch service providers. On the left, you will see that we make use of a variety of deployers for a variety of types of satellites. Not only are we able to provide launchers, deployers for CubeSats and non-satellites, we also provide them for microsatellites, as well as other payloads. On the top left, you'll see 9 easy pods, which are specifically for CubeSats and nanosatellites. On the bottom left, you see a picture on which the quadplex, also specifically for nanosatellites, but also the oldish satellites, which was a microsatellite, which we also provided the adapter. Furthermore, on the right, you will see that some of you might recognize different silhouettes. We make use of several launch vehicles, including Indian, several Russians, US, and working on other nationalities as well. To give you an idea and to define a little more, the launch service provider is defined as the operator of the launch vehicle on the launch service broker, which ISL essentially is an intermediary and we act on the end of the satellite developer. For satellite developers, it means that we can fully arrange a launch such that the satellite developer can focus on satellite development. Furthermore, the satellite developer has an experienced partner as representative for questions or inquiries towards the launch service provider, and this also reduces the overhead travel and documentation resources as well that you as a satellite developer might have. For the launch service providers on their side, they have an experienced partner as a single point of contact for many of their piggybacks. This allows for standardized interface control, documentation, and test reports. The launch service model works as follows: that from the satellite developer perspective, that as a satellite developer, you obviously have at some time a launch need. This launch need will define some orbit parameters, including altitude and degrees, and also preferred launch periods. Based on that input and some other inputs, negotiations will start between US satellite developer and ISL as a launch service broker, and this might eventually end up in a launch service contract. This launch service contract, for instance, has a match of your, let's say, your orbit parameters and launch parameters with a potential opportunity launch opportunity. This launch opportunity is the baseline, but also several possible backups. If for whatever reason that baseline opportunity is not applicable anymore, then there is a possibility to shift to another launch opportunity which suits you better, depending on the timing. This might involve some rearranging, but that is the overall model. Once you have signed that launch contract, typically the following services are included, but it needs to say that the contract can be adjusted to numbers, including excluding additional services. Generally, the launch services include negotiation and contracting of the launch itself. Obviously, there's a lot of planning and logistics involved, which is really nice. From a technical point of view, there are many things to think about, which is also organized by ISL application. The launch adapter allowing you to be mounted onto the upper stage of the launch vehicle will be supplied. Furthermore, coordination of the environmental tests is included. This means that your spacecraft will eventually be allowed on launch vehicle. Prior to launch, there's a preparation campaign which requires a considerable amount of coordination. And finally, the actual mounting of the satellite on the launch vehicle is included. To give you an idea, the customers that we generally provide service for are range from individual first-time satellites to established satellite developers. There are many challenges that are faced by CubeSat developers. Obviously, there are technical ones. Items need to be matched, need to be integrated properly. From a managerial point of view, obviously, planning and scheduling needs to be in accordance to your schedule and planning. and also there are items like legislation, items related to legislation that needs to be considered. To these changes, I would like to elaborate a little bit in the following slides. If we go to slide 8, the mass and size and envelope of a CubeSat, if we take the CubeSat as an example, what is the standard? 1 kilogram per unit, 1.33 kilogram per unit, 2 kilogram per unit. It doesn't really matter. If you're heavier than that ratio, you can still be launched, albeit you might have to pay for it. In addition, the launch reactors that ISIS and ISO make use of are namely the Isopod and the Quadpack are qualified to 6 kg per 3U, which translates to 2 kilograms per unit. We then go to slide 9. Additionally, the standard cross section of CubeSats is 100 millimeters. But it doesn't stop there. Deployables, for instance, there is additional space for that, not only on the lateral sides, but also on the top. The Isopod and Quadpack are designed to have more room than the standard fuselage. Go to the next slide, orbit deployment analysis. Obviously, the orbit depends really on your experience of payloads that you have on board. But generally, it should be that you orbit is somewhere between 400 and 700 kilometers typically, and due to the availability of launch opportunities, the information generally is some sequence. What needs to be pointed out is that as CubeSats generally are articulate payloads, you cannot describe any orbit that you will be injected in, and hence true synchronous orbits for CubeSats are rare. Hence, it is important that you, when you define your mission, when you design your payloads, to be as flexible as possible with respect to orbit parameters. We then go to the deployment side of things. The deployment involves some specific things as well. It can be in a dedicated configuration, meaning that you have a slot in the deployer for yourself, or you can be shared configuration, meaning that you have to share your slot with a deployer with other satellites. Ballistics is another item. It's primarily determined by the exit velocity of the CubeSat, and it's something that needs to be looked at carefully to prevent any unwanted activities or occurrences. But that is normally pretty accurately organized. Then if we go to slide 12, testing model velocity. It says that requirements driven by launch vehicle, which is a true statement. However, I would like to point out that you perform testing and the launch service provider provides those levels in order for you to design your spacecraft such that it will have a chance to actually function once it's in orbit. If you cannot withstand the loads and endurance during the launch, then there's a reasonable chance it will not function in orbit. Hence, the design will need to be verified once it will become allowing you the best chance to have a functioning satellite in orbit. There's a few model velocities with respect to testing. Typically, it's the qualification checklist, testing velocity involving an engineering model, and afterwards a functional model. Sometimes the prototype model test velocity can also be applied, but that needs to be redone prior to doing so. Another issue would be frequencies, which is described on slide 14. If you do make use of amateur radio frequencies, you still need to coordinate between vessels with the IARU. And the myth that you don't have to go through the ITU anymore is not true. You still need to notify them. I would quickly like to touch upon some legal aspects, although in the other session about legal and government framework, I anticipate it will be discussed as well. Satellites can sometimes be seen as dual use grids as well, so payloads can on board. So there might be export control and restrictions. Furthermore, there is the space aviation rules stating that Satellites will have to be orbited out within 25 years. That's not a lot in many countries yet, but it's becoming something that many countries want to adhere by. Finally, many countries have some legislation regarding licensing and registration of space objects, and so that's another interesting legal aspect. Then another issue that will be important will be the logistics, transport and travel issues that are described in page 16. It's considering a launch site is a desolate place by definition. It involves quite some logistics efforts, and it's also some work thought of what to bring and when to bring it. One other thing when considering the launch phase, the amount of activities that usually take place there are linked to checking out the health of the satellite, to battery charging, and finding some defining the final integration of the satellite within the deployer, or even to the launch vehicle. Planning there is critical, and also making sure you bring everything into. Although, and obviously preparing what you bring as well. So laptops, cameras, and phones are often you can bring them along, but it just needs some preparation. Finally, what timeline are we generally looking at when for launching a CubeSat or an aerospace or anything else? Typically, it takes 8 to 18 months to get all the paperwork done. And one thing to specifically keep in mind for CubeSats or microsats, but satellites not being prime satellites, that you do not have any influence on the timing of the launch at all. So, to conclude my presentation, what can you do to make it easier for yourself? Be flexible in terms of own requirements. Try to minimize the use of difficult items, and if you have them on board, arrange for license on time. Start procedures for frequency coordination notification with the IRU and the ITU as early as possible. Obviously, make sure you get onto the national legislation authorities, and finally, it also helps if you get in touch with us, for instance, for about launch opportunities, such that we can make the best possible match between your project and the applicable and appropriate launch opportunity. So, with that, we go to the next slide, number 20. I would like to thank you for your attention. If you have any questions, please send me an email on launches@easyspace.nl, and furthermore, I will be available for Q&A at the end of the issues sessions. So that's it for now. Once again, thank you for your attention, and I hope you have a very enjoyable rest of the day with all the other interesting presentations. Thank you very much. Bye bye.
As Michelle mentioned, he will be joining us in the afternoon session on mission support. He'll be available online then for any questions about this presentation or the technical information we're giving. At the moment, I'd like to welcome our next international speaker, who's also Skyping in. We have a strong representation from international speakers, but they haven't been able to cover here, unfortunately. And we have David Masadi from the Von Karman Institute talking about the science and challenges associated with the QB50 mission. QB50 mission is something that is very specific, or Australia has a specific stake in, as we have 3 satellites participating in that. So I'd like to welcome David to begin the presentation. It's online, it's just suffering from slight AD problems.
sorry for the presentation on one side. So I'm going to present the project, and today I'm going to talk about also touch some points on scientific investigation and supporting things that we are preparing on for the CubeSat measurements. So today I'm going to go into introduction, talking about CubeSat objectives, some of the activities we're performing, the status of the project, some scientific objectives. I will touch some points into the methodologies, into our sensor unit that we are developing for CubeSat teams. And then we will talk about some results, so the tools that we're using to predict the thermosphere phenomena, which is the global thermosphere model in one case, and on the other case, the tools we're using to simulate what is the environment, so the topology is around its CubeSats when we fly above between 400 and 200 kilometers. Then I'm going to conclude and give some near future works that has to be done. So CubeSat has 4 major objectives. So the first objective is indeed to achieve a facilitated access to space. So give a sustained and affordable way for small-scale research missions to access to space and perform planetary exploration. The second main objective of CubeSat is a scientific objective, and is indeed to investigate lower atmospheric characteristics, which up to date are not very well investigated. The third objective is indeed to perform in-orbit demonstration. So CubeSat will offer a platform for technology demonstration. In this case, CubeSat will offer technology demonstration for commercial flight, application study, and also for sales. And then the last but not the least is to educate future engineers and scientists to be more reliable CubeSats in this case. So here I'm going to give you some of the main activities of CubeSat. So CubeSat basically is dealing with sending into space around 50 double CubeSats into a LEO orbit. It's around 400 kilometers altitude in January, at least in the first quarter of 2016. So CubeSat will carry out unprecedented science campaign that will probe the thermosphere, the lower thermosphere, with fragmented sensors in more than 40 satellites. CubeSat will indeed demonstrate new CubeSat technology, starting from deployers to attitude control system, and then these systems, these technological systems, technology that the consortium of CubeSat has already developed, has already been flown in first supply in June this year. So here are some of the status of CubeSat. So as just I mentioned, we have flown a first supply with CubeSats in June 2014 on board of Modular. So the OPEC, which is our main dispenser for CubeSat, has flown successfully with the precursor. Then 2 of our sensor units, the IMS, which is an ion mass spectrometer, has flown and working, and it's actually working right now in orbit. Then all the NMS 14s, so the flight model, have been manufactured and already shipped to the team. Then there is a second set of sensors, which is PIPEX, which is a glass probe measuring oxygen and atomic oxygen in the atmosphere. Also, these have been flown into the first mission. Flight model is then manufactured and shipped. And then the third unit is a landing probe, which is already manufactured and then to be shipped in 2 days. To conclude again, IQ frequency coordination has been completed, and we are very looking forward for the FRR of the CubeSats starting from July this year. So, which is the main objective of CubeSat in terms of any scientific objective? So, CubeSat will perform multi-point fragmented measurements of the thermosphere, focusing on the poles and over the equator. So CubeSat will measure with unprecedented spatial and temporal resolution the anomalies of the thermosphere, namely the aurora, for example, or the equatorial electrojet. then CubeSat will be able to compare and cross-correlate all the flight data, because we are flying similar units on different CubeSats, and then we will be able to validate and enhance the physical models, given in this case, to model the upper or the lower atmosphere. So here I'm going to show you a bit of what the sensor units of CubeSat look like. So we have three sensor units. We have an ion and neutral mass spectrometer. So on here on the right side of the page, you will see a graph showing altitude on the y-axis and density, neutral density of all the species in the atmosphere. So there you see on the graph which are the ranges of measurements for the three types of the sensor. So the first ion and neutral mass spectrometer will measure neutrons and ions of oxygen, atomic oxygen, nitric oxide, and molecular nitrogen. So then we have CubeSat, which is a flux probe experiment. Basically, we will measure atomic and molecular oxygen in this range, and then we will have a Liability probe that will measure the electron density in between 10 to the power 2 and 10 to the power 6. So to perform or to validate and predict what the atmospheric processes that we're going to analyze during the 50, we are going to use the global atmosphere model developed by University of Michigan. This model is a physics model, physics-based, which uses Navier-Stokes equation for density, velocity, and temperature, and solves neutron and ion in a couple fashion. So this model can perform a or one simulations with the assumption of no horizontal flux. The input for these models are solar flux, indeed all the solar activity related inputs, which is solar flux, solar wind velocity, the spherical power index, and the planetary here. So as an output, we can compute all the 6 knockout, the 5 ion speeds in the atmosphere. We can compute neutral winds, ion velocity, and the like. One of the particular aspects of this code is the fact that it's not using constant gravity acceleration. So it's not using an only hydrostatic solution for the vertical advection, which will be give us the possibility of implementing Coriolis forces and centrifugal forces in the computation. Moreover, the code is able to compute, to resolve explicitly chemical reaction in a non-steady fashion. This code is indeed a work in progress, and it could really much benefit from the measurement that CubeSat will be offered. So, in this presentation, I'm going to show some of the comparisons we perform with the given code against some of the satellites already known. One of the satellites for the comparison is CHAMP. It's a very well-known satellite for density measurement. And the second example will be the ASTAR, which is a European incoherent scatter radar, which is located also in Sweden. And this radar is measuring electron density in the vertical profile. So here I'm going to show you some of the typical results of CHAMP. So basically, on top we have a plot which shows latitude and longitude. Then you show the density, okay, on a particular day at 400 kilometers altitude, and on the bottom you see basically one of the classical outputs of CHAMP. So you see the density over time. Basically, the satellite is rotating in the atmosphere, rotating above the Earth, and is measuring some depth. So I want to point out some of the features here on the atmosphere. So, for example, point 1 and point 3 are located on the poles, of both South and North Pole, while 2 and 4 are located on the equator. So, to compare with the flight measurements, we have to select some say, solar activity fields. So indeed, we know that the sun is one of the major external drivers into the atmosphere. Therefore, we selected 3 different solar activity. Here you see a graph of solar activity. So this is the solar flux. Basically, over the years, you see the classical 11-year cycle of the sun. And we selected 3 periods: high, medium, and low activity. And we perform computations, simulation with the Beacon code, and we validate these measurements of this simulation with chart measurements. So here you see some of the validation we performed at low, medium, and high activity. So you see again density over time for 3 different cases. As you can see, the best cases apparently from the computation looks like the medium activity, where we have a very good fitting with the chart data, and we have an error which is, let's say, less than 20%. While for the low and high activity periods, we have a negative and a positive bias respectively. These 2 features of the code are still under investigation. Moreover, we can even, as I said, we can even compare data computation with the A-scatter measurement of electron density. Here you see again electron density on the y-axis and the time on the x, and you see again comparison with data computations. So here we compare real-time data versus non-steady computation with a time relative of 30 minutes for data code, and we see an error of electron density which is, let's say, between 5 and 10%. So this is a very good agreement for the electron density computation. Moreover, what we are performing for Cube50, it's also some correction to the measurement. So when you are flying a CubeSats into a medium, in this case a very, let's say, 3-molecular domain, so we have our sensors that are basically placed in the wrong direction, so they're placed in the destination region of the CubeSats. So if you're thinking about this, say, these CubeSats flying to the medium, you might have some flow topology like bow shocks and so on, which we can influence actually the measurement of forming into the atmosphere. So, for example, if you are taking into account an altitude of 120 kilometers, if you are familiar with the CubeSat number, in this case we use a trailing path of 3.5 meters divided by 0.2, which is a characteristic length of CubeSat. We end up with a CubeSat number of 73. It tells you that we are in a 3-molecular location. So, which means that basically the response equation does not hold anymore because it's not a coherent. So what we have to do is to perform some direct simulation Monte Carlo. So these Monte Carlo simulations are necessary to solve Boltzmann equation in a probabilistic simulation. So basically, these computations are solving particle-to-particle collisions, and I'm making a lot of these collisions, making some averages, some statistical averages, and then I'm outputting the values. Here you see a picture of a typical, DCMC computation where you have the shuttle flying into the atmosphere. So I have not a lot of time, so I have to summarize a bit the results. So here you see normalized Mach number for different cases. Different cases as 100, 150, and 300 kilometers altitude. And the outcome, I can go to the outcome directly, which is following. So okay, here. So if you compute, for example, the mass flux in this destination region, so you have a number of particles that are hitting the surface of your CubeSat, so destination region of your CubeSat, you can compute a relative error between the free-stream number density that is imposed to the code and the particle mass flux that is indeed impacting the destination region of your CubeSat. So what you can see on the table there, it's basically you can compute an error in the number density for different altitudes. And what you see here is that the error in number density is above, let's say, 0% only at 100 kilometers, where you do have a shock, because indeed the flow is not so diluted as we might think. Above 150 altitude, yes, sorry. Yeah. Yes. So then I can do this. So we can complete the same. We can perform also let's say computation with different angles of attack. Here also we can compute the error density, and so we can extract basically a correction that is necessary. So a formula that is correcting basically the measurements of the QB50 sensors based on the pointing knowledge and the pointing accuracy of our cubes. So to conclude then, basically PITAM shows very good results, very good simulations for channel flight data for medium-term activities, while positive and negative bias are under investigation for low and high activities. But we also see that DCMC computations show no Gauss effect, both on chemistry and on densities, on neutral densities above 150 millimeters. Moreover, DCMC computation has shown that the pointing accuracy must be taken into account for correcting the density measurements of the cubes of the QB50 sensors. And the last point is that, yeah, I'm sorry for that. Okay, thank you very much.
I'd like to thank David for his presentation on the science of the issue. Just out of interest, this is a 3D printed model of one of the QB50 satellites, so it gives you a perspective on what gets packed into the capabilities of CubeSats and what the actual size is. The orange bit is the INMS that you referred to. Okay, our next speaker is Chantal Capelletti from the Gauss team of launch services in Brazil. She'll be talking about the Gauss alternative launch solution.
Okay.
Yeah.
Yes? Can you hear me?
Yeah, excellent.
Okay. Can I start?
Yeah.
Okay. So, good morning. I'm Chantal Capelletti from Gauss. I'm very glad to give you this short presentation about our launch solution. First of all, I want to introduce you a little bit what is Gauss. Gauss is a small company based in Italy, in particular in Rome, and is a pretty young company since we started our activity just in 2012. Really, we are a kind of spin-off from the University of Rome, and we started our activity now as a small satellite as a university in 2000 with the launch of the first Italian university satellite, UNISAT-1, in 2000. What is more important for our company is not just the service that we offer to our customer, but is an important educational aspect and the research. So we are doing our activity to maintain our possibility to make research and to support educational projects. Our main activities are related to launch service for microsatellite, CubeSat, pocket cube, CubeSat, and in general for all kind of nanosatellite. We also perform in-orbit tests of different payloads that can be hosted in our satellite. And we normally perform the design and the manufacturing of our microsatellite. Also other microsatellites from different customers, CubeSat, Pocket Cube, CubeSat, and in particular electronic and hardware for different kinds of satellites. We are also involved in space debris observation since when we were inside the university, we were delegated to the Italian Space Agency to the ADC, and we are still maintaining our activity in space observation, space debris observation. We designed 2 new observatories in Italy, and now we are performing some new observatory also here in Brazil. This is a small history of our group, our team. We started the activity as a university in early 90s, and we had the first launch in 2000 with UNISAT. After that, we launched as a School of Aerospace Engineering 6 satellites, one each 2 years. We launched 4 UNISAT, 1 EUSAT, and 1 CubeSat. With the CubeSat one was launched in the Vega maiden flight. The other satellite was always launched with the Dnieper launch vehicle, since we have a very good relationship with Cosmotros. This is the company that provides launch service from Dnieper. In 2012, unfortunately, our school was temporarily closed, and our activity was stopped for a while, and we decided to go from the public main to the private one. So in May 2012, we established our company, and so just a few people, and then just in 2013 we launched our first satellite as a company, the UNISAT 5. In order to maintain our activity and also have the possibility to be free to perform our research, we came out with this solution to have a satellite that is itself a satellite deployer. It means that UNISAT is like a motor ship able to release in orbit different kind of satellite. For example, in 2013 we performed the first launch ever of Pocket Cube, launching 4 Pocket Cube, and also we launched 3 CubeSat. The first Peruvian CubeSat, the UMSAT satellite from Spain, and the first Pakistan CubeSat iCube. Our activity are all actually continuing, and in 2014 we launched the UNISAT 6 with the deployment of 4 CubeSat. In 2015 we are going to launch the first mission able to release in orbit CubeSat. This mission will be called TUPOD and will be performed using International Space Station. In 2016, we have already scheduled a UNISAT 7 for the driver that has the capability to launch 12 CubeSat and up to 60 Pocket CubeSat. So now we are looking for a customer that want to launch with us in this launch opportunity. So why we decided to go in this direction? Because last year there is the interest on small satellite, particularly from a university point of view, but also private company, government agency, is increasing a lot, and in particular is needed to offer launch for this kind of mission. Actually, the small satellite, the bigger satellite, has no more the one that was designed 10 years ago, but there is some technology, some possibility that is increasing the number of the launch requests, also the technology and the capability of the satellite itself. This is a small idea of how the launch of small satellite are increased in the last 10 years. So just in the satellite less than 10 kilos, or in particular CubeSat, are increased a lot in the year of between 2012 and 2014. For example, the launch of UNISAT 5 was a launch with more than 32 microsatellite launched in just one shot. And in 2014, the launch of UNISAT 6 was also bigger, since there was more than 34 satellites in this case. So the idea is to use a satellite as a platform, because this kind of solution can give some advantage. In particular, in this case, you can have a fast multiple alternative solution. You can also have a cheaper launch. You can avoid the creation of dangerous loads for example, when you have a big launch, launch with a lot of satellite, you can have a high risk of collision. But in this case, you have a platform that will go far away from the main, from the fairing, and the possibility to release after a while the other satellite. For example, in Dnieper, launched cluster launch of 2014, we scheduled our release mechanism to release the satellite after more than 25 hours. This time can be selected by us in order to avoid the collision, but also in order to put the satellite in a different position in the orbit. The future goal of our idea is to have a platform completely autonomous, but also with an orbital control system able to help a small satellite to create a constellation. Now, one of the constraints on the design of the development of microsatellite project is related to the difficulty to perform constellation mission. Because to release satellite in different positions in the orbit, or in particular kind of orbit, is very expensive. With this kind of mission that's called SATCAR, we can release the satellite in a particular position on the orbit and help the possibility to adapt the formation of new constellation. Can you hear me?
Yes, I have comments.
Okay. Up to now, is everything's okay? Okay. So now I want just to present some of the. So our platform, in particular, here you can see the satellite we launched in the UNISAT 5 and UNISAT 6. In UNISAT 5, we launched CubeSat, it's a very difficult name. That is one new CubeSat IQ, that is one new from Pakistan, and UNISAT that is from Spain. All of them are working correctly. In particular, UNISAT D is giving a lot of testing result, also for humanity mission. In this mission, we also launched for the first time ever the Pocket Cube. Pocket Cube, I don't know if you are familiar, but it's a new kind of starter invented by Professor Fix. Professor Fix is also the inventor of CubeSat, together with Professor Jordan. So now, with the Pocket Cube, the idea of Professor Fix is to create a platform even smaller than a CubeSat. The dimension of a Pocket Cube is a 5 centimeter cube with a weight of about 200 grams. In the mission of UNISAT 5, we launched 4 Pocket Cube. One was for equal to with a dimension of 1.5 p. That means 12.5 centimeter in height. And Brandon was the smallest satellite launched. Brandon was a satellite with a dimension of 1p, so just 5 centimeter cube, but with a lot of technology. In particular, it was equipped with a pulse and plasma thruster, with a reaction wheel, but also with camera. After the beginning of the mission, they had some issue because it was very difficult to contact the satellite. But after a couple of months, they received very interesting data from their satellite. The other 2 satellites was CubeScout and Eagle 1. In particular, Eagle 1 is also called the $50 satellite, since all the satellites at a very low cost of about $150 for all the electronics, solar cell structure, so all the satellites. In 2014, we launched the UNISAT 6 mission, and in this case, we didn't launch Pocket Cube, but we launched just CubeSat. We launched Antelsat to you from Paraguay, Lemur. It was a review. CubeSat was the fifth satellite from Iraq, designed also in collaboration with our company. And the RQ6, that was two satellites of altitude together, that was separated in orbit. To the back. Okay. 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 I will go into it. So this is our platform. Our platform to release the satellite is very easy. It's very similar to the other kind of platform. The difference is the lighter, and it's using fungible as an opening system. Fungible is a high reliable, qualified system to release to open the door of the release mechanism. We are also have other kind of format to release satellites, so pod to release up to 12U, pentapod, and G-pod. In this case, we use a new kind of material that make our platform lighter, but also customizable. So if some customer need to have a different kind of format, we can design and perform every kind of launch. So this is our strategy. This is our system to release Pocket Cube, and this is the specification of this release. And this is a new kind of deployer that is itself a satellite that is called T-pod. T-pod is a project to release CubeSat in orbit. Up to now, there is no possibility to launch CubeSat in orbit because also in the orbit that we will present later, we show that for now they can launch just to suborbital mission. But with this kind of system, we can board the CubeSat inside a P-pod and release the P-pod. The mission, the first mission, will be at the end of this year. We will launch a CubeSat made by high school, medium school in Brazil, and another CubeSat, and we will release from the International Space Station. So this is just 1 second. Can I finish?
Yep, very quick.
Hello?
Yes, if you have a conclusion slide.
Yes, just 1 second. This one is the launch of Unison 7, just to tell that our launch vehicle is the Neptune launch vehicle, but we can perform also launch in accordance with Japanese Modular GEM. We perform launch from the International Space Station. Up to now, 4 satellites have been scheduled to be launched thanks to our cooperation with this company GEMS, International Space Station. And also we have a contract already signed with the second floor from Alcantara Second Space in Brazil, H2A, that is a Japanese launch vehicle, and with the Soyuz. So thank you. This is our contact. So if you have any questions, please.
Okay. I'd like to thank Chantal for that presentation. Now we've reached the point where we can have some morning tea, so I'd like to thank you for your attention so far. We'll have a quarter of an hour for morning tea. It will be both inside and outside, actually the same stuff. So spread yourselves out. And we will start getting to the end. Thank you.
All right,
Let me try to figure it out.
I think you have to stand here because that's like where the speaker. Sorry. It's crazy. Not reserve, but also we prefer to practice.
Yeah, can't quite see as well.
I don't know if we told them. Yeah,
the video is like yesterday, right? Well, so I used to be like, I used to be one of the ones that do this live.
exact time, you don't tell me when I need you to. As you can save that time. Yeah, if you you're like, okay, I'll be quick. It's like, okay, so one slide.
I don't envy your job. Sorry, I don't envy your job.
Yeah, you know, even at the press, it's like this press pass that it's not even I'll be like, oh, whatever, like, oh, so yeah, but somehow it's going to help out.
It's good. It's slightly scary.
Yeah, so that's
Exactly. Like last week, I mean, my team was and so like, we had a lot of intel policy of classified
Sorry, you didn't go live. Oh, he's playing So I found that yeah, we still have videos just being yes. Some things audio. So it's not short to the. I mean now it's just. Yeah, so you can switch it to that one and rotate to the audiences. And I think this is so that it's quick time. You can tell how many just change to this camera, and then we'll do like rotate. Just to Say hi.
Yeah, yeah. I got it on. Thank you. What do you do?
No, I just sit there and say, wow. And in terms of typically negative models, because as opposed to something unique, it's very focused on me. So they spend a lot of time going, they might I don't know.
And I know you work with
Yeah, we'll see what happens. That was the idea. I want to say that. If not space, yeah. It's just because I think it's just about like programming.
yeah. You like
So I sort of ignore what's actually going on. And sort of like when you I sat down, I saw how well it is. I kind of want to
I'm very that's
if you do that, though, then actually have you might see
yeah. Yeah.
It's not bad, right?
I have the audio is actually really good, or it's trying to cancel out the noise or something. It's not actually
So nice. I grew up in Belgium.
Hey, how's it going? Good. A couple of guys that are streaming from home and stuff reported that there was a desync issue in the in the Skype window stuff. So they're saying that there was like a significant amount of lag and glitches, low res of the Skype feed being injected into the primary feed.
there will be a lag.
No, it wasn't lag. It was like really bad quality. So the rest of the stream was really good, but then the rest of the Skype feed itself was pixelated in comparison.
So I'm just trying to. Like this is actually checking live.
Oh, that's hilarious.
So I think probably if you just try to switch it to 720p, I think it should be good.
You can switch it to Skype now.
Yeah. Oh, okay. So if you just try to 760, this small, we do not give you this small thing, you just give you this.
It's not just saying that there's stuff there to spray up. Far worse quality than else.
Yeah. Actually, what happens is if you just go for the full screen one, you will get the full one.
Yeah. But I don't know. They'll just say.
Yeah, I know what you're saying. Like this thing will not give you anything yet. So probably we'll have like at least this much of the screen.
Yeah.
We tried it, like having done less than that. So we tried to do it with the high resolution, but
Oh, cracking it up. Get back to it.
yeah.
So usually being able to see the long range, probably because it's more forward range, so this is a range and the final getting into Western Australia and a missile corridor for 4,200 kilometres long out into the Indian Ocean. The actual construction of the range began in May 1947, and the first aircraft landed at Moray on the 4th of July 1947. The first trial, parachute trial, was conducted in December 1947, and the first missile was fired in 1949, and this was the first of about 6,000 over the next 30 years. The reason why Woomera is so important is because it's a very busy area. Airspace we can control from 0 to infinity. It's extremely safe because of the very, very low population density, roughly 1 person per 1,000 square kilometres. Despite the fact that there are 4 mines operating out there, these mines are actually just little pinpricks, dots on the landscape, and that really don't get as much from it at all. Also, the security of the area, because of its remoteness, effectively very few roads, it is extremely secure for us to be able to conduct the type of trials that we can do up there. It's also flat, which makes it easy for and ideal for recovery of physical drop-off or the land after test, and we do actually go out these days to recover every single piece of range projects that we fire out onto the range. Importantly, the range is electronically very, very quiet. It's one of the most electronically quiet ranges in the world. Encroachment on ranges, particularly in the United States, has rendered a lot of them particularly difficult to use for modern electronic warfare type trials, but Woomera is ideally suited. That's one of the reasons for the major resurgence in the use of Woomera as a weapons system. Between 1947 and 1980, the heyday of the range, of the old range, there was around 7,000 people in Woomera, in a very remote community. Amazing, interesting stories about what people did and how they made their life interesting up there in that very remote spot. The roads were very bad to Woomera, and the main way of getting out of Woomera was either by train or by air. The picture you see here is of the main rocket launcher area in Lake Hart. There was 4 planned, 3 started, 2 finished, but only 1 used in the end. Another part of what went on at Woomera was the atomic bomb tests that were conducted in Maryland and the Modular Islands out to the west of Australia in the 1950s, a controversial period, of course. And it's probably one of the things that made Woomera an extremely well-known spot around the world back in the 1950s. Another important thing often overlooked in the history of water was its support to the NASA Gemini Moon mission programs. And there were 3 stations, the one at Red Lake to the north of water, Hurricane World to the west of water, and right on the Moon, another Deep Space Station 41, about 27 kilometres south of water. The range you can see that all the equipment's obviously gone. And in fact, the big dish that's shown in the picture there works so well that it was actually just taken back to the United States at the end of the Gemini program in the early 1970s, and is still in operation in the United States today. In November 1967, such was the knowledge of Australia, and obviously we had the rocket launch facility, that we were able to design and build our own orbital platform. And in fact, the RearSat rocket and the orbital platform was launched on the 29th of November 1967. This effectively made Australia the 4th nation in the world to design and build its own satellite and put it into space on its own territory. Unfortunately, it's the only time we've ever done it. Another major program that existed at Woomera for over 30 years was the Joint Defence Project for Others, which was established in 1969, just in south of Woomera, about 18 kilometres south of Woomera. That project closed in 1999. The JDF Defence Facility for Others was part of the US and NATO Global Constructive Communications and Response System. And it was jointly operated by the Australia and the United States. In 2007, Woomera's unique role in the global development of aerospace technology was fully recognised by the world-renowned American Institute for Aeronautics and Astronautics. This essentially proclaimed the WTR, or Test Range, as a world historic aerospace site and put it on a rating that said it was of similar importance to tranquility based on the Moon, where the first human set foot, and also physical in the United States, where the first civilian aircraft flight was conducted back at the beginning of last century. A quick look at the governance and strategic management of the range now. This slide that you can see now is what we call Woomera on the page, and essentially shows the main features of Woomera, including the rat base in the bottom right hand corner, which consists of Woomera Village and Woomera Aerodrome, and then what we use the range for on a normal day-to-day basis. So you can see testing of UAVs, launching of rockets, testing of electronic warfare, firing missiles, dropping bombs. That's all we do on a daily basis. The Chief of Air Force, as the capability manager of the Woomera Test Range, is an intention for the Woomera Range complex, and in simple terms, this is what it says. Firstly, that we are a warfighting enabling capability, so we enable the main parts of the Defence Force to conduct operations by making sure that the equipment that people use, the systems that people use, work as they are advertised to work. So we primarily exist, therefore, to test and evaluate war material, all sorts of war material. We're operated by Air Force, but we also exist to support the whole of defence and other national requirements. And under other national requirements, that means things such as supporting space research, which is not just in the war material. And you might remember back in 2010 when the Japanese JAXA Corporation brought back the Deep Space probe from an asteroid, and that space probe landed at the Woomera Test Range after its long journey of about 7 years. So that's an example of national requirements, which is just the war material. We don't have enough space to do that type of work, so the fact we're very busy doing normal defence work. The organisation of the range, the Woomera Range complex, the Woomera Range headquarters is based in Adelaide at Great Base Edinburgh, and essentially at the headquarters oversees access to and use of the Woomera Range complex. It has its own legislation, and that controls the range, and that's pretty well what the Woomera Range headquarters is responsible for ensuring that the use of the range is compliant with that legislation. The range has 2 major formations, which is the Woomera Test Range, which is run by the Woomera Range Trials Unit, and Rat Base Woomera, which consists of the air base and the village. The air base is run by number 20 Squadron Rat Base Woomera, and Defence Support and Reform Group from the Defence Department look after the operation of the village. The Woomera Test Range itself, the ground area is known as the Woomera Permanent Area. So we have the Narumba Test Area, the Woomera Restricted Airspace, which is all the airspace over the permanent area, and Camp Radio, which is another part of the range there, or it's actually contained within the Rat Base itself, which is controlled by the range. The actual range itself, well, we exist to enable the testing of war material to deliver more effective warfighters. That's our mission. We don't actually conduct trials ourselves. What we do is create an environment for the flight users of the range to come in and conduct the trials. And when we conduct those trials, to meet our mission, we operate in 4 main areas. First of all, we provide operational environments for the testing of air and space-based weapon systems, the testing of ground-based weapon systems, the testing and disposal of hazardous war material, So old weapons such as melt bombs and rockets, we take them up there and blow them up and get rid of them. And we also provide the opportunity for the conduct of force preparedness and other warfighting readiness, training, testing and evaluation, which is our new development. This is very much about the modern network integrated warfighting that's required. This is very much where the ranges go for the future. The Women Capital is unique, and we are the only asset in the world which is capable of taking forward the next generation of weapon system within our land borders. And this is one of the reasons also why the ranges become very, very important, and this is essentially back to operation after a hiatus of around about 25 years. Through joint activities with our Navy allies, we play a key role in Australia's design status as an emerging member of the world power, and over the next 7 to 8 years, the range has been progressively updated to meet the ADF's defined needs for testing and evaluation support through 2035 and beyond. And as an example of outputs that we have, strategic outputs, particularly what we call research and experimentation. So this is the stuff that you might not see on the ground for 20 to 25 years. And a good example of that is the hypersonic engine testing that is conducted at Aura. These engines, when they're fitted to airplanes in the future, will take you from Sydney to London in 2.5 hours. At the operational level of work, this is about maintaining the force of being. So we have a lot of weapon systems that are actually in position or in service at the moment within the ADF, and it's very important that these are constantly tested to make sure that they don't do what's required of them if ever this is the situation. At the tactical level, we provide direct support to operations. So this is business that are actually in country, overseas and operational service. There are a number of activities conducted for it, which is a direct support of those activities overseas, known as a priority one task. And in particular, what we see here is CIED task force work, which is the counter improvised explosive device, which is the roadside bombs. This is a huge problem these days, and the work to counter those IEDs is incredibly important work, and a lot of that is carried out in Aura, particularly at the moment. This slide also shows a major area of development work that goes on at Aura. This is for UAVs. And you can see in this particular slide, the top left is METAS, which is a program that was conceptualised, designed, built, and trialled within about 18 months. And the British did that back in 2011, 2012. First time they conducted a program at this stage since the Second World War. Other aircraft you can see there, the bottom right hand corner is the Air Force Coherent program, which is currently based in Aura and continues to operate there. Quick overview of the range itself. As you can see, most of the facilities are concentrated in the bottom right hand corner. And this is because of the huge distance that are involved in the range that most of our infrastructure is close together. So past here is what we know as the peripheral standard target area, and that's about 115 kilometres away from the village. Ranging is about this within the range. In the range here, you can see there's a little yellow dot there, and in the actual range map, that yellow dot is one of the 3 areas that's actually owned by the Defence Department. Defence is not any of the border area apart from a small spot range here at the village and at the logo. This map gives you a slightly bigger picture of our infrastructure in that bottom right hand corner. You can see in the Runga area just to the south of the village, in the bottom right hand corner, and that's about 80 kilometres south of the village. About 6 kilometres north of the village is the airfield, and then about 30 kilometres north of the airfield is range here. That's where we do most of our large scale explosive testing, up to about 100 tonnes of explosive. Out to the west of the airfield, we have the lake area, where we do a lot of our warfare testing, and range here, which is our instrumented range, which we have time and communication telemetry information, radars and optical instruments stationed along the civil line, and that's basically capture the behavioural characteristics of weapons that we just fire at the range. This picture shows the range control centre, which is a very large building. It's situated about 45 kilometres west of the village, and the building is capable of holding about 400 people. So it's quite a large facility, and it's essentially our main rocket control, range control facility. Another couple of areas of the range which are quite important is Camp Ranger, which I mentioned. This is a secure, specialist combat force preparation and support facility, mostly used by the Army, has an independent village complex been established in there, and this is where a lot of the diggers do their training before they go overseas to search for and find bombs and bomb making equipment and that sort of stuff and weapons. So they learn a lot of techniques and facilities here before going overseas. In the Runga test area, as I've already mentioned, this is where we do an enormous amount of our counter-IED and EW trials activities. This is a very busy site now, the 200 days a year that's available for use. Actually, we use about 2 days a year, so it's a very busy site. The type of people or main users of the range, pretty well all the Australian Department of Defence. So with the Ministerial Director, we get direction from the Vice Chief Defence Group. That's where the CIO and Task Force people are attached to that particular group. Equals headquarters and force element groups of the Air Force, which are obviously a main user of the range. But we also have the Australian Army, Naval, and other forces, special forces which use the range. We're not a training range as such. We don't allow particularly manoeuvre across the ground, so it's really don't own it, it's quite fragile. Most of the stuff we do is in the air. And we also support the Capture Development Group, which is the Australian System and Innovation Office, Defence Material Organisation, Defence Science and Technology Organisation, and other special programs that are run by the Defence Department. We also get national tasks and free for the Prime Minister's and Cabinet area. A lot of that's to do with disaster relief work and Department of Innovation, Industry, Innovation, Science and Research, which is where programs such as NASA and space research activities come through. And these are non-military programs, and also the famous Liability program from Japan comes through that office. On the range itself, we have targeted communications box telemetry, which is often attached to the weapons and rockets that we fire, so we can track where it is. And then we also optically traffic and radar track it as well. Our systems on the range are specifically safety systems, designed to make sure that if anything happens, the weapon being tested or the vehicle being tested as it goes off track, we have the ability to cut it down inside the safety checkpoint. And that's obviously a major part of the work that we do. We don't actually collect the information itself on the weapons that are tested stuff on the flights. We simply operate the range control safety system. We have air and ground live flight ranges, ultra warfare testing ranges, ground-based weapon system areas, large and small scale disposal warning system areas. We can conduct space launches and recoveries. We have, as I said, already said, the range control and safety area facility, and we have large ground target facilities as well. So the next generation of Modular comes towards the end of the brief. This is about what we're going to do for the future, and essentially our equipment is very old, so over the next 7 to 8 years, all our radar systems, all our timing communications will all be completely upgraded, and by around about 2019, 2020, the range will be one of the most important in the world. Just a brief look at the Modular support base itself. There's two main areas of the base, the Modular aerodrome area, which is about 6 kilometres north of the village. This is within the troop area. The Modular village itself remains open to the public. The airfield is a 7,500 foot strip capable of operating every aircraft in the ADF, including a heaviest aircraft with 3 hands, the air interior, base area, refueling area, all the same areas, and we operate all fast aircraft types. The village itself is our domestic support area, but it's open to the public. We have approximately 150 to 200 basic units, and we can support up to 400 transit personnel on any one day. We also get around 80,000 visitors a year to look at our 3 museums. And these are the main services of the range. We have 3-star hotel flight events, and obviously that's our main support facility for the range activities. A lot of people come to what I say, oh, nothing happens here. That's essentially the body to on the range, so we really will actually do that during the day. Camp Radio, which is only about 2 or 3 kilometres from the village itself. There's another 200 beds in there, and that's basically the understate that they come to work. So we just come, range numbers of 150 to 180 people. So they like to be in Camp Radio. The medical clinic and the RSDS support. We have a lot of trial support services that are necessary, and this is made everything from the hire of a vehicle down to supply of special fuels. Security services, including the South Australian Police Service, operate out of the village, a swimming pool, many social clubs and radio station with a 560 seat conference theatre and conference facility at theatre. Banking and post office agencies, religious services, bowling money, thanks to the Americans when they left. They left their bowling money, which is very nice of them. And as I said, we have 3 museums, the Coherent and Missile Park, which is quite famous. We also have fitness and squash facilities as well, and a range of sports clubs and other social recreation clubs. So that's the overview of the Modular range complex. I hope you found that interesting. And if you get the chance to visit Modular, it's a good idea to get up there, stay the night, spend the day and walk around, stay another night, and then move on to some of the other areas around the Modular, such as Liability and the Newspace, which is without a doubt also worth a visit. So thank you for that, and I hope you enjoyed this brief overview on the Modular range complex.
We now move on to our next section, which is on the legal and government framework associated with launching from Australia. And we have Ross Cook from the Special Nation Office, here to talk about some of the legislation's legal requirements associated with space activity.
Thanks very much for that introduction, Jonathan. My name is Ross Cook, and this is Mark Todd. We are from the Space Coordination Office, which is a very small unit in the Commonwealth Department of Industry and Science. So I'll just emphasise that we're not a space agency. We're now looking at half of the Space Coordination Office, so we really are very small, and we try to do a very broad range of activities. Our primary role is as the first point of contact and coordination within the Australian Government on space-related matters. So that means that we actually connect with a lot of different agencies across government. But we also have a responsibility for industry development and for space regulation. And it is our regulatory role that we'll talk about today. So this presentation is to give you some context on the why, the what, and the how of the Space Activities Act. So some of you may feel that space-related regulation challenges your ability to conduct space activities in Australia. We do understand that. We understand the frustrations. You also probably know that the government has a very strong deregulation agenda with a view to reducing the red tape burden on business and improving efficiencies in the economy. However, the Space Activities Act addresses a complex range of issues and facilitates a number of international obligations that Australia has. In the short time that we have with you today, we hope to give you some understanding of the context in which the government actually looks at legislation such as the Space Activities Act. So why does Australia need to have space-related regulation? Australia is signatory to 5 international agreements on space. This means that Australia is responsible for Australian space activities both within Australia and by Australians, no matter what entity actually carries out these activities. The treaties address a range of matters, and almost all spacefaring nations have signed and ratified at least the Outer Space Treaty, the Liability Convention, the Registration Convention, and the Rescue Agreement. The final one, the Moon Agreement, is considered to be a failed arrangement, and while Australia is a signatory, hardly any other major spacefaring nations have actually signed up to that. So Australia's commitment to these international agreements occurred in the late 1960s and 1970s, and Australia entered into these without enacting any domestic legislation to give effect to these commitments. At the time, this was considered appropriate because most of the activity was actually being performed by the Commonwealth Government. However, the circumstances changed with the deregulation of the Australian telecommunications sector in the early 1990s, when Australia's domestic communication satellites moved into the private sector. This drove an enthusiasm for investment in satellite systems, which then in turn fueled private sector proposals to establish commercial launch facilities. This activity was actually the driver for recognising the need for Australian space legislation, and the Space Activities Act was developed to implement those obligations. An effective regulatory framework needs to produce net benefits, which means recognising both the benefits and the costs broadly. The Act is actually an enabler for activities in space. It recognises the global nature of space activities and Australia as a responsible global citizen. It provides a framework for investment in Australia and by Australians, and it manages the risk of public liabilities, and that's risk to the public purse that results from private gains. But we must also recognise that regulation can actually be an inhibitor to innovation. It can impose real costs on business and discourage investment. It can be inflexible and difficult to change quickly. So balance is important. That can be very challenging in a fast-changing environment, particularly where technology is the driver of that change. We've seen a lot of examples of that in today's presentations. The space regulatory framework is comprised of 3 documents. It's the Space Activities Act, the Space Activities Regulations, and the Approved Scientific and Educational Organisation Guidelines. The key concerns of the Act and the regulations are to protect public safety and property during launches, and to ensure that launch operators are able to compensate in the event of accidents, and do this either by insurance or by assuming direct financial responsibility. The scientific and educational organisational guidelines allow a different licensing and fee regime for those in the commercial organisations, and this is really to encourage research activity. It does this by reducing the fees to 1/10 of the commercial rate, which is quite a significant saving. However, it's important to note that the criteria for being granted a launch approval remains the same as it does in the commercial space, including the liability components. There are 4 types of activities that are covered in the regulation. Space licence, which is required to operate a launch facility in Australia. However, a licence doesn't give you permission to launch or return a space vehicle. This needs to be done by a launch permit. But a launch permit can only be issued to the holder of a space licence. But if the activity is launched overseas, so that's for launches in Australia, if it's launched overseas, you need a return of an overseas launch space object certificate. And that is for return of an object anywhere in Australia. The most common approval granted under the Act is an overseas launch certificate, which is issued for where an Australian national has an ownership interest or any part thereof of a payload or launch vehicle. There are also a couple of other considerations. One is an exemption certificate. Exemption certificates may be issued under exceptional circumstances called launch permits, space licenses, and return of an overseas launch object. They are not able to be applied to an overseas launch certificate. Australian government activity is not bound by the requirements of the Act, but Australian government agencies must still comply with the requirements of space treaties. This mainly applies to defence activities, but it's important to note that if a private company is partnering with the Commonwealth Government, that company would still need to get the necessary licensing. And at that point, I'll hand over to Mark Todd to talk with you a little bit about how activities are processed under the Act.
Thank you. What actually happens when you submit an application under the Space Activities Act? What goes on behind the scenes? It's a special mission control area, the Department of Industry and Science, that receives the application. Applications are actually submitted to the Space Licensing and Safety Office, or SWASO. You may have heard this name before. SWASO is not actually a separate team within the department, it's a separate function. It is one of the functions of the Space Coordination Office. It is one of us. The best way to explain the how is to briefly go through the process for the submission. I will assume that an overseas launch certificate has been submitted. We undertake 2 main tasks: SWASO assessment, as well as a recommendation brief to the Minister. The SWASO assessment. The first thing we do is register the receipt of the submission with the applicant. We then begin a process to assess the application against all the regulatory sections of the Act and all the relevant sections of the regulations. Some of this is simple, such as, was a submission submitted in writing? Do we have a contact person? However, some of the regulations are more complex, such as, is there enough information to enable the Minister to make an informed decision as to the probability of the launch causing substantial harm to the public? I would also like to highlight a couple of the key areas that we search for when a submission is when an application is submitted. Does the payload contain any nuclear material? Is there enough information to register the object? Is there evidence of the probability of harm to the public as well? Is there evidence that the insurance and financial requirements have been satisfied? Has the application fee been paid? The assessment process also involves a lot of consultation, because consult with our government stakeholders, with the applicant, and with our internal legal team. We consult with the applicant if the application is missing a piece of information, or if we are seeking further clarification. For example, in relation to safety, we may ask about the safety record of the launch vehicle, or we may ask if any risk mitigation activities have been undertaken. I will just quickly wrap up with the Minister's approval. The Minister is responsible for the final decision on whether the overseas launch certificate should be granted, and you can see what he considers up on the screen. Assessing an application does take time. It is important to communicate with us early. Space.gov.au also has a number of helpful resources, such as guidelines. And I hope this quick overview of the what, the why, and the how has been useful.
Thank you for that. Now, continuing with the session on the legal frameworks in Australia, the formal word, sorry, give it a time. From Optus, talking about yes, the process of obtaining missions to launch targets. I think that would be. Okay.
It might be that. Standing where you are is fine. It's like the palm.
Is that back to you?
Back's better.
Yeah, back's better.
Okay. Well, you're supposed to make me down around. Once the rockets go up, they come down where they like. That's not my department, says the good Dr. Pike. And as who knows the good Dr. Pike? Dr. Pike, Dr. Glenn Pike was the Optus rocket scientist for many, many years. And he retired a little while ago, but he's still a presence that is felt. He, unlike the statement, which is a slight rip-off from Tom Lehrer, Dr. Gordon Pike was in fact the quintessential responsible space engineer. Because once the rockets go up, he was actually very concerned about where they come down. So following on from the discussion about how to get an overseas launch certificate, because I'm assuming that many of the CubeSats that you guys are contemplating, guys and gals, are likely to be launched overseas. In my very short little 10 minutes, I'm going to focus purely on what you've got to do to get an overseas launch certificate. And I'm not going to go through everything, read the instructions. I'm going to go just address one question, and that is, how do you satisfy the insurance / financial requirements? Because they're the ones that give you all heartaches. So hands up who in here who is an engineer. You. Hands up who has ever actually launched a small rocket or has dreamed of doing so in their backyard. Was the first thing you thought of, I better get insurance? No, it was not, because that is not how you think, and that's okay. I know that. I'm a lawyer. I've been involved in 6 launch and build and launch programs, and I know that that's not naturally how engineers think. But the good Dr. Pike, who when I first arrived at Optus gave me a collection, a copy of the Space Activities Act and a collection of all of the space treaties, was himself very concerned about where the rockets come down, whether it's going to injure anybody, and if it does, or damage property, and if it does, who is going to pay? And so that is what the world was concerned about back in 1967 and again in 1972, and they made these international treaties. If you hit something on the way up or on the way down, who is going to pay? And they made an agreement. And there's no point people in this room complaining about this agreement. They want to go and become diplomats because the agreement is there. If you hit something on the ground or a spacecraft in flight, it is your fault, even if it is not your fault. So, and when I say your, I really mean the government of Australia. And that is why you've got to get an overseas launch license, because if your little CubeSat hits something on the way up or on the way down, the Australian government has to pay. So that's why it makes sense for the Australian government to say,
okay, if you're going to launch one of these things, and if you're going to strap it to a 20-ton bomb, we are liable, we are responsible to pay for any damage you do. So if you get an oil and gas platform, and this teeny-weeny little harmless thing happens to be strapped to a 20-ton bomb, all Rosenbach are responsible 100% for all the damages that happens, which is a pretty shocking thought. So that's why the Australian government says you've got to get a license and you've got to think about insurance. Now that all sounds like really terrible news, because if you look in the Act, it says you have to get up to $750 million worth of insurance, and that'll do your head in, right? Like, why should this have to have that? Even if it is strapped to a bomb. It seems crazy. I'm here to tell you about the loophole, if I've got enough time. Otherwise, just a little okay, here is the loophole. The Act says you've got to show maximum probable loss or get up to $750 million worth of insurance. My advice is don't go down that path, right? Just you're rather not want to read your nerdy maximum probable loss calculation. No, they do not. I bet they do not. What they want to know is, if you blow something up, is someone going to pay? And that's what these clever little regulations that we voted for, not stupid, that's what they provide for. So as long as you can show someone is financially responsible, you're okay. But the important thing is, you've just got to address your mind to it very early. Now this is great news. This is the really great news. Someone is responsible for it. They're called a launch provider. And the launch providers have been doing this for a long time, or except for the new ones, but even they have got pretty decent legal teams. They know they've got to buy insurance, and they do. They buy insurance. Now, how much does it cost for you to be named on that insurance? How much does it cost the launch provider? Nothing. Nothing. So, when you make your arrangement with your launch provider, even if it's through a third party, make sure you get named on the insurance. It costs them nothing. It costs you nothing. You just have to do it. Just do it. So even though you're engineers and you don't like thinking about things, you like thinking about rockets and how we're going to get it up. Do think about what happens when it comes down and who will pay. And if you think about it early and you put it in your first discussion with your launch people, you will be able to get it in there. At least I think so. I haven't done it for CubeSat. I don't know, but I've done this 6 times now, and it can be done. And I don't think people who, I don't think it's hard for people to give away something that costs nothing. So you just need to find the right approach. So that's my say to the industry. In your first discussion with your launch provider, don't just talk about the cool rocket stuff or the cool deployment stuff. Talk about insurance. And talk about what's called indemnity. So the launch provider is going to give them an indemnity for the third party. So in other words, they say we will pay the third party loss. The launch provider already knows they have to pay for that. They just need to confirm to your third party launch intermediary and to you, and then head to the Australian government that they'll do so. So all you need then is a certificate, is some sort of document that says, yes, we got that indemnity, yes, we got the insurance, an insurance certificate, and then name the Commonwealth Government on it. So this is the loophole. Get the insurance certificate from the launch provider, costs them nothing. Name any of the CubeSat owners, just generically, doesn't have to be specifically, and name the Commonwealth Government. And sweet. So be like Gordon Pike as you go out into the world of launching things. Be responsible like Gordon Pike. Know your legal obligations. Know that what goes up may or may not come down and may hit something. And take what steps you need to look after the space environment. Be conscious of how it's going to come down, what it might hit, and what it might be in the way of. Not messing up our environment because it's a space we all want to play in. And do what you need to do to protect the Australian government, yourselves, and also your institutions. Because speaking as somebody who is in the legal department, you've got to think about Uni of New South Wales or whatever university you're from or whatever organisation you're from, because the Space Activities Act is going to make them pay if they don't have the insurance. So they need to you need to protect your institution's money. Yeah.
Super good question in the time you got left.
Yeah.
After the initial launch period is up, which is approximately 30 days, something like that after launch.
Yeah, yeah.
There's an increasing area of liability about in-orbit collision, which I think the Act doesn't yet cover. Any thoughts on that quickly? What are you guys thinking about there?
The Act doesn't yet cover it. We certainly do. We certainly get insurance that's launch plus 1 year, and the launch providers think about it. So and at the end of the day, the launch providers that are deploying you, they need to think about it. They need to buy insurance. You need to be able. That's what I think.
Well, the question is Phil, after a live presentation, the leader people up at once. Question was a panel. Okay, I would like to introduce the last of the party, who's a senior lecturer here with engineering, and is also dealing with the legal aspect of launching CubeSats for the University of New South Wales, and also is now teaching on the space law topic part of the Masters in Space Systems Engineering.
I think that was Jack Cycles for Donna, not for me, right? All right, thanks, Barnaby. You've heard from Rose and Mark, you've heard from Donna. What you're going to get from me is sort of builds on those two, because I'm going to assume that you know a little bit about the Act and the loophole. Now, what Donna's said basically talks about how to go through what we've got now, the legislation that we've got now. What I want to deal with through my experience on QB50, the legal side of it, and through my extensive research in what other countries and what other nations have done, what I think is a good matter for debate in how to go forward with this. Now, we are at a unique time now. The reason is you've heard from Tim about this sort of unique situation that space is in with the emergence of CubeSats, of small satellites, and the fact that Australia has an opportunity now to re-enter the space industry, or the global space industry, to grab some market share. So how can we act? Ross said that legislation has to strike a balance between inhibiting or regulating and not inhibiting innovation. So this is what I want to deal with. I have a lot of slides, but I'm going to skip through most of them. The one thing I want to say about the legal context is, as Donna said, liability is absolute. Okay? During the launch phase, if something happens, regardless of whether you're at fault or not, you have to pay. And what we mean by that is a state is responsible for its subject, so the state has to pay. In orbit, liability is fault-based, so it's a different story. Now, interestingly, Australia is a party to the liabilities, to the treaties, as Ross mentioned. So we have to deal with this issue. Now, we've heard what's unique about small satellites. So Don's been dealing with large satellites. With a large satellite, you've got a large budget. You've got access usually directly to the launch provider. With small satellites, we've got a lot of different mechanisms at work, a lot of different circumstances. For starters, small satellites can hitch a ride together. Small satellites are low cost. Their rapid mission from concept to end of mission is a short time. Usually, the mission is established in a few months or to a year. The mission lifetime could be between a few months to a few years. So all these things using off-the-shelf components means that we can actually, like I said, we can enter the space industry and we can grab market share. We've got access. It provides a level playing field. However, this can be inhibited by legislation or by the length of time if what we do is not helped along. Now, what's wrong with the Act? The Act is actually very well given. National space legislation has to, if I skip one slide ahead, national space legislation has a primary purpose under the space treaties to regulate and protect. So under space treaties, a state is required to supervise and authorize and supervise the activities of its subjects. It's also required to protect the liability, okay? Protect itself, to reimburse people who suffer damage. However, when we look at other nations, we see that their space acts add two things that Ross has alluded to, two things to their purpose, and that is to just facilitate and promote. Unfortunately, so when we look at the US Launch Act, it specifically says to encourage, facilitate, and promote, and puts that first, launch activities, and to develop a licensing agreement. When we look at the Australian Space Act, we see that the Australian Space Act, you can read the preamble, you get access to it on the internet. It says it allows Australia to meet its obligations under the Liability Convention, the Registration Convention, and so on. It refers to liability and insurance. Okay? What is missing here is the facilitating promote. And this is what we need to address. So, what can we do? Now, if we look at what other nations have done, and this is specifically, this is come about because of this emergence of small satellites. We look at the UK, they decided to cap liability at £60 million. The Netherlands, limited to the sum insured. When you read about the Dutch Act, it actually says what insurance is available. So it doesn't ask for unreasonable insurance. France, 60 million euros. Belgium, maximum 10% turnover of the entity launching. So BKI, their annual turnover average over 3 years is 12 million euros. They're liable for 1.2 million. The government picks up the rest. Austria, limited to 60 million euros. The USA, has something similar to us, but in effect, when you read about it, it limits to it's got a limit of less than $100 million. And in fact, the launchers have specific liability limits. So when you look at a Delta rocket, I think it's $70 million. Okay. Australia, we're left with this NPL or $750 million, whatever is less. So there is a burden for satisfying if we can't get access to the launch provider or for whatever reason. So as I said, the Act is well written. However, it must facilitate and promote. Some recommendations. The first thing Tim asked about this. One thing about the Australian Space Activities Act is it was written, as Ross mentioned, it came as a result of this flurry of activities into initiating launch from Australia. So it doesn't really, the overseas launch certificates and launching objects, Australian objects, not necessarily from Australian launch facilities, really came almost as an afterthought. So unfortunately, the reality is that that's the only thing that we've got. So launch facilities in Australia haven't got that. What we've got is the afterthought. So we must clarify the in-orbit legal status. When you look at the liability, if you've got the Act as it is, does not allow for sharing of liability. But when you look, if we've got 3 Australian satellites on the same rocket, Australia is still a single launching state. The liability is still the same. So why don't we combine the applications into a single one? Makes sense. Another thing that you see other countries do is they exempt research and education institutions. And there's a value in doing that. Now, I want to talk about liability. The government caps our liability at $750 million. So the government is in effect an insurer for any liability above that. It acts like an insurance company, right? It's willing to pay. So the recommendation that I've got is why you cap the liability, this $750 million is really a measure of what you value the industry or the activity to be. If the more value it has, and the lower value is basically risk-benefit combination, the lower your value that you attach to it, this cap that you have. So let's look at let's look very quickly at the recommendation. If you allow 10, let's say that the government now reduces the cap to a value C. So the government essentially is picking up, is being an insurer for the difference, $750 million minus C. Okay? Let's say that we have a probability of an incident that is less than P. So if you go through the calculation for K launches, so I'm not going to go through the mathematics, but it's essentially what you end up with is for a small number of launches and for a reasonable probability, a cost to the government, that is the number of missions times the probability times the liability times this difference from $750 million to whatever they cap it to. Now, if we look at this as an example, if you have a probability of 10 to the minus 3 of an accident, 1 in 1,000, and you have 10 missions, the numbers that I in there, then the actual probability, the actual cost to the government is 7.5 million. Okay, so if the government places a value of more than that, if we can convince the government that we have a value more than that in the missions that we're doing, this, remember, this is picking up. This is the government picking up the entire liability. So this is capping the liability at 0. This is requiring liability at 0. If you take that up to $60 million, you can change that. This becomes a little bit less. Now, just before I finish, this what I'm putting up is not meant to be what it's meant to be sort of a start, just some thoughts for debate. The last thing is that if we facilitate this is more a word of caution. Australia also has a responsibility under the United Nations for debris mitigation, the guidelines. If we facilitate CubeSat missions or small satellite missions too much, the CubeSats are non-maneuverable, and they basically become projectiles in space. So we need to make sure that we don't exacerbate that problem. One way to do it is to limit the orbital altitude until such time as maneuverability is available for CubeSats or mechanisms for deorbiting. I think I've covered it all. Thank you. Yes.
I'm going to ask Ross and Martha to answer one or two questions from the audience about this. Yes, at the back.
How many times do people involve this insurance game, right? And often there's a personal liability disputed for. So, how many times has this actually been invoked?
The insurance or the...
Yeah, how many times has someone said, oh, your satellite's framed into ours, we want them to be invoked?
I don't think the liability prevention hasn't been invoked, but there have been a number of settlements out of court for objects hitting other objects or landing on the ground. I know a barrister who's in the UK, and her name is, believe it or not, Darcy Beamer Browning. That is her real name. And she is a space specialist, and she has a fairly busy time settling claims that you don't read about them anyway.
Actually, there has been an incident. There was an incident in the 70s that led to the liability. In the 70s. There was an incident where a Russian satellite landed in Canada and had some nuclear material, and it was USSR at the time in 1979, I think. And the liability convention was used, but the first instrument in the liability convention is diplomatic means, and the matter was sorted through diplomatic means. So the USSR paid $3 million Canadian dollars to the Canadian government. There have been collisions in space, but in space it's a fault-based and it's a very difficult thing to enforce.
Although I understand that things happen.
Yeah. For the region, yeah. Okay.
One more question.
Yeah, in the constellation launch model, it's increasing the complexity of the notion of a launch as well as an orbit. And you've got the potential of launch carriers and satellite makers and so forth going into massive litigations because someone else that's piece of the constellation brought down the mission or caused some sort of explosion. How robust is the present legislation framework to deal with that, and what's the likelihood of it resolving?
Well, I was going to say that the obvious answer is the legislation doesn't deal with what happens in orbit.
I I would just say that when something happens in space, sometimes you can't tell whose fault it was, which is why a lot of the contractual, quite apart from the treaties, the contracts are generally done in a way that is on a no-fault base. So the contracts between the insurance, the launch provider, the manufacturer, the owner, there's a suite of contracts, and they all tend to be no fault. Fault is allocated on a time basis, as in when did it happen precisely, which is why your definitions about when the launch happened, when the terminated ignition happened, have to be very precise, because it's about time, it's not about failure. And sometimes people have trouble getting their heads around. But we had it really happen when our B2 satellite had a failure on a China Long March. The Chinese still say our satellite blew up their launch vehicle. We still say their launch vehicle blew up their satellite. Doesn't have an insurance back.
All right, thank you very much. You know, we should talk to at lunchtime for further questions. Now, it's my great pleasure actually to invite Peter Beck from New Zealand's Rocket Lab to talk about the new launch vehicle, the electron launch vehicle that they're developing there. This has been making quite a lot of news recently, especially with the venture centers in the US and securing various amounts of financing contracts. Yes. And once we sort out the AB, yeah, we're good to go.
Cool. So thanks very much. I'm sorry I couldn't be there in person today. We've got a bit to do by the end of the year, so couldn't make it over there. So I'm just going to run through a real quick presentation and then open for up questions. It's probably the most use of time. So first a little bit about Rocket Lab. So we started in 2007. In 2009 we became the first private company in the Southern Hemisphere to reach space with a suborbital space shot. Since then we've had over 80 successful sounding rocket launches of various forms and kinds. We're recognised as world leaders in propulsion and GNC. Before we started the Electron project, our biggest customer was the US government, mainly DARPA. We are a US company now, although the New Zealand entity is a wholly owned subsidiary of the US entity, and we are Silicon Valley venture capital backed mainly. So our key investors here are Coastal Ventures. They're a $1 billion Silicon Valley Tier 1 venture capital group, and at the end of last year we closed our final round with Best Venture Partners, very old venture capital firm once again in the Valley, and we also have strategic investment from Lockheed Martin. I'm not appreciative of the converter here, but we've just seen such a massive growth in the small satellite industry. Out of the Space Reach report last year, they showed a 269% increase in the small satellite market. Interestingly enough, if you look at LEO satellites, they've decreased in mass 75% in the last 5 years. So GEO are getting much bigger and LEO are getting much smaller. But the really exciting thing is if you add up all of the currently active and funded programs that are advertised, there's nearly 1,100 kilogram or 100 kilogram equivalent flights required in the next 5 years. So 250 of that are just CubeSats, so aggregated CubeSats, 200 kilograms. And then we have other programs like, there's all sorts of other programs which are advertised. And then we see the likes of Google now entering the market, and they're talking thousands of 100 kilogram class satellites. So really, really exciting time for small satellite and satellite in the industry. But there is one problem. There's two fundamental things that we need to do to really enable this market. Small satellites are being produced in record numbers, but launch vehicles and launch opportunities are. And if you're trying to be commercial with a small satellite, there's two really important things that you care about. One is we have to reduce the cost. And cost per kilogram is not really a relevant metric. It's how much capital do I need to get my asset on orbit where I want, when I want. And then the other thing is increased launch frequency. So if you get a ride that's free, you've got to wait 2 years to get there, you can't be commercial. So the two things we have to address here are cost reduction and increasing the launch frequency. So this is where we've developed the Electron launch vehicle. So it's a two-stage, 100 kilograms or 500 kilometer sun-synchronous capable launch vehicle, or we can loft 400 kilograms to a horrible orbit. But this is a good, true circular sun-synchronous orbit, so it's a proper orbit. Currently, the price is 4.9 million, which is the same price that that roughly costs you for a ride share by the time all things are said and done for 100 kilograms. But the really unique thing about what we're trying to do here is build this launch vehicle and launch it in very large numbers. So everything we do here, all the innovations that we have are designed around about how we can build a launch vehicle at time frames and at the cost points and the volumes we need to. So the launch vehicle is an all-carbon composite launch vehicle. We don't do it out of carbon composites because it's kind of cool and new. We do it because we need to be able to produce tanks in a rate and at a cost that only that manufacturing process and material performance will allow. So everything we do is built around how do we build this vehicle for production. And we started with a total clean sheet here. We said, okay, we want to launch at least once a week. How do we go about doing that? So we put no constraints on the program whatsoever. And we didn't tie ourselves to any heritage components whatsoever. We said, right, we're going to solve this problem. And part of the reason that we're down in New Zealand is solving that problem. So we went to the US ranges, and it's really tough to support for more than once a week, or even a once a week flight out of the US ranges. There's too much air traffic, too much shipping, there's just too much going on. So the only reason we're in New Zealand is because of the launch range. So the launch range that we've established here, we can shoot south to go sun-synchronous right up to 46 degrees. So out of one range, we get a huge azimuth of orbits, and there's just nothing to hit. We intersect like two commercial flights, and that's it. We have a huge window of availability, which is really, really important if you're serious about launching once a week. So that's really the program in a nutshell. So I'll throw the floor up for questions, and please go for it.
Okay, thank you, Peter. So we have a few minutes definitely to ask some questions. Open questions up to people.
Yes. How's it going, Peter? How are you feeling about your progress?
Good. Yeah, we're aiming for our first flight at the end of this year. When you're trying to do this, it's not just about building a launch vehicle. We're building a whole launch range. There's a whole lot of regulatory stuff that we go through. We fly under an FAA license, so we're right in the middle of FAA license applications. So if it was just building a rocket, it would be great. But there's a whole lot of pieces of moving parts to get to the first flight. But overall, we're tracking well.
Thank you.
I have one question as well. Are you supporting CubeSat launches in terms of developing your own payload deployers as well, or are you going third party with that?
So we have a couple of things there. So we do have a third-party aggregator that's sort of ones and twosies. So if someone's got a 1U or a 3U or something like that, then generally we've got a third-party aggregator, which we'll be making an announcement on shortly. But if it's a whole mission, a whole launch vehicle, or a campaign of multiple launch vehicles, then that's the time that it's great to engage us. But ones or twosies, we would probably do that through an aggregator, but certainly would never nobody should ever hesitate in contacting us, because if we have a little bit of space, then you know, we quite easily you know, try and accommodate anybody that turned up.
Fantastic. We have time for maybe one more question. No? Okay. That was a fantastically clear presentation. Well, thank you, Peter, for your time. Appreciate you phoning in. And your contact details are available to the audience, so if there are any follow-up questions afterwards, they may get in contact. So,
right, thanks very much.
Thank you. Okay, so continuing on the trend of the launch vehicles, we've got a video presentation now from Nano Systems on launch opportunities that they might be able to provide coming from Australia. This again is another new launch technology and presented by Conrad Goldberg.
This is a presentation of launch opportunities for and from Australia by the two Norwegian companies, Modular Space Center and Nano. Launch opportunities for and from Australia. Norway is developing a low-cost launcher and launch service. The North Star launch vehicle will be based on non-hazardous and environmentally friendly hybrid propulsion. Modular Space Center will provide launch services to the NSLV, but also to other small launchers, expendable and reusable, through the proposed service, Polar Satellite Launch Service. PSLS is currently in a pre-project phase, set to finish by September 2015. The final go or no-go for the full PSLS program will be given by the end of 2015, based on the pre-project findings. Launches will be completely controlled from launch to orbit using already existing Norwegian assets. Export of North Star launch vehicles to Australia will be possible. Headquartered in Tromsø, Norway, the Nano Group is a technology-driven aerospace and defense group specializing in high-performance defense and space solutions. The company was founded in 1998, based on a merger of three major Nordic defense companies: Celsius AB, Patria Orge, and Tromsø ASA. The Nano Group shareholders are the Norwegian government, represented by the Norwegian Ministry of Trade, Industry and Fisheries, and the Finnish Defense and Aerospace Group, Patria Orge. Three areas of interest triggered the decision of Nano Tromsø to invest into hybrid rocket motor technology: affordable and safe rocket motors for sounding rockets, environmentally green propulsion technology, thrust regulation. Affordable. Hybrid rockets are inherently safe, and most of the oxidizers are readily available in industrial quantities. Only green oxidizers were considered for implementation: liquid oxygen, hydrogen peroxide, nitrous oxide. Since 2010, the number of activities has increased rapidly, primarily because of a strong interest of the space community for green propulsion technology. Modular Space Center is located in Norway and is the world's northernmost permanent launch facility for sounding rockets. ASC has conducted more than 1,000 sounding rocket launches since 1962. ASC is also specialized in development and integration of payloads. The technology department developed optical sensors for detection of particles, gases, as well as imaging systems. In the recent years, ASC has been host to several technologies testing missions as CheapX, HiFire, and HTR. ASC has developed a remotely piloted aircraft capable of beyond line-of-sight flight, carrying a variety of payloads. Part of ASC is also the Alomar Observatory for Atmosphere Science, which operates both active and passive instruments in coordination with research institutes from all around the world. ASC employs over 70 people among scientists, engineers, and technicians. The ASC facilities include a payload assembly hall, a control tower, wideband mobile and stationary telemetry and ranging station, a science control room, workshops, and other buildings for rocket storage, assembly, and various operations and maintenance functions. The Visitor Center offers meeting rooms, an auditorium, and exhibition space. ASC also offers a customer service center, including 32 hotel rooms, kitchens, laundry, gym, and relaxed facilities. Our clients include ESA, CNES, DLR, NASA, JAXA, and international universities and institutes. As a limited company, ASC is owned 90% by the Ministry of Trade, Industry, and Fisheries, and 10% by Koningsberg Defense System. ASC is an ISO 9001-2008 certified company. Ondea has its own airport close to the town center of Andenes, located at 69 degrees north, 16 degrees east. Daily flights to and from Oslo via Uda or Tromsø are available. The airport also serves direct flights to and from Oslo using the airline company Norwegian during summer and autumn. A coastal steamer, bus transport, a bridge to the mainland all provides additional methods to get to and from our island. Due to the Gulf Stream, Ondea has a mild coastal climate with winter temperatures 0 plus or minus 5 degrees Celsius. The last 5 years, about NOK 250 million has been invested at Ondea Space Center. New infrastructure like a payload assembly building, over 30 new offices, an auditorium for 100 persons, a new industry kitchen with connected cantina, classrooms, new telemetry equipment like Cortex 25 to 30 megabytes per second receivers, 5 10-foot mobile tracking antennas, a tracking radar, and so on. Our latest investment is a new 23-foot tracking antenna arriving autumn 2015. A learning and experience center, the Spaceship Aurora, was opened by the Norwegian Prime Minister in 2014. Ondea Space Center was established at Ondea, northern Norway in 1962. The location was chosen due to the fact that the Aurora Oval sits above Ondea during nighttime. Centered at the magnetic North Pole, the Earth's rotation will move the oval overhead Svalbard during daytime. To enable launch of sounding rockets into the CUSP and daytime Aurora, ASC has established a launch site, Svalbard, at Neolesen and Svalbard. Getting data from a sounding rocket while it's flying is, besides launching it, the most important task for ASC during our operations. Ondea Space Center has completely renewed its telemetry capacity. New wideband Cortex receivers, new antenna controllers and motors, and more. A new 23-foot antenna is in the process of being purchased. It should be installed by late autumn 2015. Ondea Test Center, a subsidiary of ASC, is providing tests and training of military technology, missile and rockets, aircraft systems, UAV test and training. By including the ATC telemetry in the ATC sounding rocket operations, and vice versa, both companies enjoy simultaneously multiple state-of-the-art telemetry systems. To make our operations even more flexible, ASC, in cooperation with the Civil Aviation Authority Norway in 2014, established permanent danger areas for sounding rockets, missiles, and RPA, covering more than 22,000 square kilometers around Ondea. The permanent zones are unlimited in height and available 1 week after notification. In addition to these permanent areas, ASC also provides temporary danger areas as remote as north of Svalbard by application. The turnaround time for application and notification is approximately 4 months. The first launch of a North Star hybrid-powered sounding rocket is planned from Ondea Space Center in September 2015. A single-stage rocket carrying approximately a 100-kilogram payload built and integrated by ASC. The ongoing Polar Satellite Launch Service pre-project will be, amongst other important issues, also need to consider if a new launch site is needed. Initially, ASC would like to use the biggest launcher at the existing site, U3, capable of launching rockets weighing up to approximately 20,000 kilograms. Due to safety or other constraints resulting from the pre-project investigations, it might be necessary to establish a remote launch site equipped with a platform launch instead of a rail launcher like U3. The full hybrid version of the North Star launch vehicle might take years to develop, but a soft first stage, second, and third stage hybrid combo or other launch vehicles should launch out of Hyundai Space Center around 2018 if the final go is given by the ASC Board of Directors at the end of 2015. Launches from Nagoya Space Center will be completely controlled from launch to orbit using already existing Norwegian assets. Wrapping up, a Norwegian launch vehicle, fully or partially equipped with North Star motors, launched from ASC into polar LEO and controlled by CubeSat, will be a powerful and cost-effective Norwegian package, contributing to less high-flying satellites that are out of service or just flying too high compared to their desired altitude. For more info, please contact Mr. Holbert Wickstone at Hyundai Space Center or Mr. Ono Bergern at NAMO.
Thank you to Dan for preparing that presentation. We have at least one member of the audience, I think, who has launched from Modular here. Russell, voice at the back. Yeah. So you had some prior experience with what it's like to go out to that particular launch site, launch from there, involved. I'm sure Russell will welcome questions from the boat and doing that. And otherwise, I'll welcome our next speaker. The Fred Murphy, who is talking about training and work services from Australia.
Everyone can hear me okay? My name's Brett Burford. I'm from AU Launch Services. I like what happens when you take a group of really smart people, give them a big challenge, and empower them with technology. They inevitably create an innovation that changes the way we do things. This is exactly what is happening with launcher technologies today. Today I'm going to touch on some of the major issues with current launch processes. Then we'll have a look at some of the different launch technologies for CubeSats that are currently under development. Right now, if you want to launch a CubeSat, chances are you will be ride sharing, and this can cause many problems for CubeSat manufacturers. When ride sharing, all aspects of the launch are going to be dependent upon the primary payload, even scheduling. If the payload is delayed, your launch will be delayed as well. Current wait times already range from 1 to 3 years, that can be longer, and the last means you have no say whatsoever over your attitude of your CubeSat. This can make some missions exceedingly challenging or even impossible. The main concern, let's say, a very brunt of the costs. The launch provider, primary payload manufacturer, are going to be much more concerned about $50 million satellites of CubeSat. Accordingly, there are additional restrictions to further ensure the further safety of the primary payload. For example, having advanced solid propulsion systems, there are limits on pressure vessels and chemical storage, and this can all but rule out other propulsion system options and more advanced missions. Launch costs are still prohibitive, with a base cost for a 1 year launch still being $50,000, and there is some variation, obviously, for time, the greater the cost. additional The Firefly two-stage rocket designed to take a 400 kilogram payload into low Earth orbit for just $8 million. This payloads of up to 1,000 kilograms. Using their aerospike engine in combination with an all-composite launch vehicle, their goal is to have the lowest launch cost in this class. We've already seen about the Electron launch vehicle from New Zealand that we've represented today. They've been designed very much with a customer focus and expect to provide more than 100 launches a year for a 110 kilogram payload. It's a 3-stage vehicle and can reach a 500 kilometre sun-synchronous orbit. CubeSat. They're a service dedicated specifically for 1 unit and 3 unit CubeSats. Their major aim is to provide a turnaround of 1 to 2 months for launching your CubeSat. Their launch costs will be similar to that of other providers, but their fast turnaround allows for savings from reduced holding costs as opposed to paying for storage and maintenance whilst waiting several years for a launch. Now for something entirely different with Zero to Infinity's Blue Star. This rocket uses stratospheric balloons to lift the rocket to an altitude higher than 30 kilometres before ignition. This approach means that the rocket does not need to expend energy travelling through the most dense parts of the atmosphere, but instead ignites in close to vacuum conditions for maximum efficiency. This is also has the added benefit that the design of the rocket itself can be significantly altered to maximise its advantages. Conspire Technology is taking a unique approach again, with an unconventional air-breathing second stage, which is designed to be reusable, while the first and upper stage is mass-produced. The aim of this system is to promote rapid response times and frequent launches, but with a focus, again, specifically for CubeSats and nanosats. Now we've talked about some of the benefits and what we can expect over the coming 5 years. These launches represent major changes to the way that CubeSats will be launched, and so it's perhaps further look at those benefits. You're going to be able to get your CubeSat to space much faster than you ever have before. There will be a very large number of launch providers in comparison to now to choose from. There will begin to be a decrease in launch costs. The potential exists for less technical restrictions depending upon the carrier and whether you have a dedicated launch or a run share arrangement. But we do need to consider that these benefits bring new questions. With so many options available for launch, how do you select the right flight for your mission? You put so much time, energy and money into your CubeSat. The last thing you need to do is make a mistake in choosing which provider is the best fit for your mission requirements. The results could be disastrous. You also need to consider how these new options may have significantly different risk profiles from current launch providers. How will this affect the insurance costs? The lowest cost launch may not actually be the cheapest flight for your CubeSat. You're going to need to make some hard calls on what's most important to your mission. A fast-tracked, dedicated launch with no restrictions and your own mission parameters will not have bargain basement prices. These things will be soon possible, but they are going to cost. So you will need to weigh scheduling versus cost versus constraints when selecting a launch provider. With new types of launch vehicles, there will also be new requirements for CubeSat manufacturers to consider. So how do you reduce the risk of possible delays and problems when you're working with these new providers and requirements? Whilst these issues do exist now somewhat with current launches, they will become much more complex as the number of operational launch providers increases, especially as there are more varied launch technologies. AU launch services exist to help overcome these obstacles and many more that we don't have time to discuss today. Our major focus is providing consulting and support for the various administrative tasks for launching Australian CubeSats. These can include obtaining your overseas launch certificate, advising on your maximum probable loss document, assisting you to find the best avenue to space, just to name a few. These can be time-consuming tasks, they can be confusing tasks. How do you get insurance? What insurers can you go with? Can you get insurance from Australia? And that's if you can't make use of that loophole, what do you do then? What about working with the launch provider and their requirements? Are their requirements clear? Are they thoroughly understood? What can you do during the design and manufacturing process to ensure the launch requirements are met? There are plenty of questions to answer. And if you don't have a launch provider as of yet, we can certainly help select one that is a good fit for your mission and your needs. We are passionate about space, and our team does have experience with the administrative processes associated with launching Australian CubeSats. So we're happy to work with you through some or all of your hurdles ahead. Flavia Takamardini, CEO of Launchbox, was unable to be here today and has asked me to say a few words. I'm sure many of you are familiar with Launchbox. They design, build and operate high-quality nanosatellites. They're currently working on a very exciting project, Australia's first CubeSat constellation, consisting of nearly 150 communication satellites, or CubeSats. I'm happy to announce that AU Launch Services is working closely with Launchbox to facilitate the launch of Australia's first CubeSat constellation. Next year, the first 2 CubeSats will be launched, followed by the remaining CubeSats in phase 2. I started this presentation talking about how smart people paired with great challenges change how we do things. They also empower others to focus on innovation. Emerging launcher technology will open new avenues for CubeSat manufacturers like Launchbox to continue to push boundaries and change how we do things. It's been a pleasure for AU Launch Services to support these forward-thinking individuals and organisations. So if you see me around the hall, come and say hi. I'm always welcoming the opportunity to chat with anyone with a like-minded and an interest in space or anything entrepreneurial. So thank you for your time.
We do have time for 1 or 2 questions if you'd like to ask Brett anything about launch procurement and the services that we provide. Otherwise, at the moment, we have scheduled in a 5-minute break for anyone who's desperate for another cup of coffee or yeah, anything else. We will start again in 5 minutes' time.
Hey, dude. Not too bad. Good seeing you. Yeah. Not too bad. Same thing. Yeah. Yeah, nice to meet you. Yeah, not on the set specifically, I'm kind of annoyed that we weren't contracted about my research project last year. We actually have hardware. Yeah. Where we're doing extra tracking. It's yeah. This is why I don't like. I'm out. This is why I hate it. But the phase they're going through right now is now doing a comparative study of what technologies might be able to be used to get virus. So that's as far as that's everything else. Everything's very high level. Like I've done the mission design for it now. CubeSat is the actual you could probably take my notes on yeah. That would be a lot of like MTS. Yeah, it would be it's going to be made in April, and then I'm like, oh, there's our recruitment. Yeah. On top of that, Saturday is just a busy day anyway. Yeah. The weekday. I'd say we have 20 to 25 people who are really neat, who show up. And then we have Neptune case and then at the moment, we may actually have like 20
Sydney runs
Yeah,
back.
oh, that's from. Is that the SSS? Yeah. I copied the profile and I used really good. But then it was so simple. I thought, oh, I'll do something similar. I put all my CD architecture.
Yeah. One of our electrical engineers, similar to mine,
Start with the next session. Okay, so continuing on the vein of launches and in particular propulsion now, we have a presentation from our colleagues out in the University of Brisbane, so fellows with Lawyer and Peter Rickness, where they've been developing propulsion systems which are suitable for small satellite launches, and they've prepared a video presentation for us on this.
Good morning from Bremen. This is my colleague, Dr. Peter Rickness. Next week, I'm propulsion, and I am currently with my work on the propulsion. This presentation will cover different CubeSat propulsion systems and delivery systems. Then we have some expertise here and so on. We will be covering some existing hardware that is already being manufactured and is existing for CubeSat with different manufacturers known in the space industry such as Aerojet, Vanguard, or satellites, and we will give some ideas of what future developments are currently taking place in Europe. After we have reviewed that hardware, we will move into the use of propulsion in a CubeSat, which currently we foresee as two different options. One, CubeSat with propulsion for the own mission of the CubeSat, such as attitude control systems, station keeping, etc. Or another concept that we had before studied, which is to use a CubeSat or a CubeSat constellation as a test platform. Namely, for example, to test a 1 Newton range thruster in the space environment. In that logic, we will try to set a bunch of requirements that the mission will need to cope with. Finally, my colleague will talk to you about our project called STERN, which is a sounding rocket that could be potentially used as a delivery system for CubeSat. Moving on, the first system I would like to bring the attention to is what we call CHEMS, which is a butane-based thruster based on MEMS technology, micro miniaturized technology that can offer different parts in normal liquid type of propulsion. We will see across this presentation that there are actually almost every type of propulsion that you can imagine has already been miniaturized for CubeSats. Second is for this example of a 1 millinewton thruster of classic hydrogen thruster that could be used and has been manufactured already by a partner that will be able to perform station keeping, for example, in CubeSat missions. The next is the chunk system developed by Aerojet. This is actually a very interesting concept on 1 unit CubeSat, 1 LISA, for example, of a 3-unit CubeSat, which can give up to 4 different axis control and have different nozzles behaving at the same time of, again, a classical hydrogen thruster. So it has proven to provide up to 300 microseconds impulse, and they have different several configurations of the package. The final actually system hardware use this sort of cylindrical single axis as configuration, but they do have all this availability.
Another example of existing hardware is the Snap 1, which is again a butane thruster. However, this storage has to gasified liquid, so it's gaseous propulsion rather than liquid. It's heated by an electrical system, as this little flow schematic shows some pictures of the actual size and the actual integration in a CubeSat. Then going to coal gas with a little bit less efficiency than the normal chemical liquid propellant, we have a huge range of existing hardware. So this is maybe the most commonly used miniaturized type of propulsion. Then, then we're going to, after we go through liquid, coal gas, we go into solid fuels, either in the way of cartridges or a small spheric fuel cell in a large number of hardware available from 3 kilograms up to 10 kilograms. As this is already a bit outside of range of a CubeSat, but the smaller ones are definitely in the range. The advantages of solid propulsion is obvious, it's reliable, it's usable, it's very common as a single system. However, it's not ignitable, it's one use only. The impulse goes from 0.6 to 1.2 kilograms per second, which is going to be very large for a CubeSat. However, the systems that exist and it can be miniaturized. From electrical, we have a lot of systems. I wanted to bring the attention of this mission we found interesting. It's the Mars CubeSat mission with an impulse of 44 newton seconds at a very, very high. As other options is the normal vacuum arc thrusters or ion thrusters. New concepts. The new concepts go in the direction that's been studied in Europe in the last years is to turn everything to green advanced propulsion. So there is a big project running in Europe currently called GRASP, which is green visual advanced space propellant, which tries to turn everything we're used to using hydrogen into new propellants. There is already existing hardware, not only in Europe, this potential business done in Korea, I believe, that try to change our, for example, the CHAM systems that we explained before by Eric into H2O2 through a catalyst that is a miniaturized either monopropellant or bipropellant configurations. The main issue here is the actual miniaturization of tanks if you want to go below the 1 millimeter range. Again, these thrusters can provide anything from 1 millimeter to, from 1 newton to 1 micrometer. Other hardware issues, which are not related to thruster again, are valves or tanks, which are the two main critical items when we talk about power. The main issues are high cost, and they're very critical. However, there are already existing options. In terms of tanks, the main challenge is its integration and seating within the rest of the configuration. You need to remember that if you do bring up one of these propulsion systems, you're probably going to be looking at this one whole unit for your system. GRASP is the initiative I was telling you before, has considered a large number of different green propellants that could substitute traditional liquid chemical propulsion. These are the main results coming from their study that we have selected their performance in the range of what we consider not as bare minimum within CubeSat. There are many options, but the ISP tends to be very low. So in the end, if we would like to use a green propellant, we will need to go into either a bipropellant configuration or a hydrogen peroxide configuration that is comparable to hydrogen. So, in this sense, what can we do now that we have decided to put a propulsion system in our CubeSat? What can we do with it? So, the heritage available, for example, from Aerojet, has immense availability as existing concepts. If we wanted to do the same for green propellants based on the results from GRASP, we will have some issues on the MENS system. There are efforts done in Austria by ESA, and there are others in Taiwan and Russia. The roadmap to achieve a green propellant system in a CubeSat will be to try to reproduce the Aerojet chunks with H2O2. Bipropellants is also an option, but the heritage is not so common, as a bipropellant system involves a more complex architecture. This would be the idea of a propulsion system with its given power budget, pressure range, and the ISP that we expect from it. So the demonstrator for a CubeSat with a propulsion system will be to try to aim to a technology readiness level 6 or 7 in space. we can perform a certain number of tests in space that we cannot do considering the restraint of the CubeSat. For example, we could do electrical checkup, performance in hot firing, pressurization, leakage, thermal system tests, and propellant storage. Currently, we know that, for example, the H2 presents some questions on its long-term storage in space. When it's impractical to use a CubeSat in space, will be, for example, to prepare parent life or lifespan test. So, of course, we cannot fully qualify a test in space, transfer in space with a CubeSat, but it's a good starting point to prove a concept. Other tests available will be material compatibility, vibration, shock, gas, and liquid phase in space or inside the tank, etc. Now I will leave to my colleague who will tell us, once we decided to build a CubeSat, put a propulsion system on it and run a mission, how do we get it into space?
Okay, thank you very much. Getting into space is very ambitious, of course. So this is just the very first steps and the very early steps to that point. It all started in April 2012 when the German Aerospace Association (DLR) started a student program called STERN, which is Student Experimental Rockets in German for short. And basically, 8 German universities are currently involved in this program. They get funding to build suborbital rockets at the moment and to design them from scratch, basically. The idea is to foster engineering talents and to get them to like space propulsion and space transportation, so that you can teach the experts of tomorrow, basically, on the living thing. So they have to design the whole thing. It is actually like a whole real space project with all typical phases of preliminary design review, critical design review. All of those stages are in there, and as I said, it's funded by DLR. Now, ZAR, or the University of Bremen, is involved with our rocket called Zephyr, which is the TARM experimental hybrid rocket. It's a small sounding rocket using paraffin and blocks as propellants. We have an engine of 2 kilograms of thrust with 30-second burn time. Obviously, that doesn't get you into space, but it's learning how to build small rockets, which can eventually turn into small carriers for something like CubeSats. That would be the ultimate goal, I think, which at least some of the groups to actually get into space. At the moment, it's very suborbital. So we have a total wet mass of about 70 kilograms. And a payload of maximum of 5 kilograms, but that's pushing it. We lose a lot of altitude, obviously, with these small rockets, and we want to be higher than the European altitude record, which is 12.5 kilometers roughly. So we want to be around about 10 kilometers. As I said, early stages, this is a technology demonstrator. So that's why we're still very low, but this can be increased in performance and developed further. It's a 2-stage recovery system, so we have drop chute and main chute to get the rocket safely back to ground. And as I said, it's a demonstrator, so what we want to demonstrate is hybrid technology, for one. Hybrids have been lingering on the edge of application for a very long time. I think now, with more and more development in that area, they actually present a good alternative to other propulsion systems because they're inert and they're safely used. That's why they're ideal for such a student program. Also, they combine the 2 things of solids and liquid propulsion, so the students can actually learn both systems in some way, which is very good. We have a lot of additive manufacturing technologies because especially when you want to miniaturize stuff in a small rocket, soon the manufacturing of small components, adapters, and all those kinds of things, especially, for example, injectors in our rocket engines, becomes very challenging with traditional manufacturing techniques. So either you ask the manufacturer to produce about 1,000 of those, and you get the reasonable price per piece, or it takes forever to just produce one prototype. Additive layer manufacturing is really a good way to get around that. And we want to demonstrate usability and rapid turnaround. So in principle, the rocket, because it's a hybrid, lands is refueled. You put a new fuel cartridge in, you put new oxygen, and the rocket should fly again immediately. And since it's reusable and reliable quickly, we hope to reduce costs basically for this. How does that look like? This is our rocket currently. We're flying in Sweden from S-range. This is some of our trajectory calculations. So we're starting down here in S-range, and we're then flying up to what is called extended zone B or zone C. Currently, because it's a experimental rocket, they want us to fly at a fairly low launching angle of about 80 degrees because they want to get the rocket away from the launch site as quickly as possible because it's experimental. Once confidence is increased, we can increase the launch angle to higher levels, 90 degrees upward, which will then give us much more altitude. And we plan to launch later this year. So the rocket is currently in manufacturing. Most major components have been given to the manufacturers, and we're still working on making it at the moment. So we have the classical design of the engine section with the fuel ring. Then we have the oxidizer feed system. So we have an oxidizer tank for LOX, which is about 14 kilograms of LOX. And we have a helium pressure tank at the top, and it's all operated by pyrotechnic valves. The payload, which would be interesting for any kind of experiment, at the moment it would just be interesting for CubeSat, which is pre-stage to CubeSat. This could be here. This could be extended, however the customer or the person likes it. And then we have the recovery system at the top, which is the two-stage parachute system. We do actually have a payload for our small flight, which is hopefully about 12 kilometers, which is the customer for that payload is FSDS, and they want to test thermoelectric generators and onboard data transmission. So they want to test how could you wirelessly transport signals from sensors to receiving stations on board computers, and we're going to way to do that in flight on a small sounding rocket, which is a good test bed for them and not very high risk because the costs are very, very minimal. So that's why they want to test it, and they chose thermoelectric generators because waste heat could be used to power some electronics, and there's many cases obviously with thermal gradient, which could then be used to power sensors in that region, which saves you a bunch of mass and cabling. So this is basically our payload for this first mission. The other payload is our own telemetry system on the rocket, which is going to be used. So in conclusion, we have shown some existing chemical propulsion options for CubeSats, also how they can be applied and how they might be useful for CubeSat missions. And I've also shown a demonstrator rocket that can be used to launch CubeSats in the future once we upscale that version. So yeah, if you have questions, because we're doing this online, offline, you can send all the questions you have to those email addresses, and we'll be happy to answer the questions offline at any time. So thank you very much for your attention, and with the Australia. Thank you.
Thank you. Now, our next presenter is from Space Systems, so it's three, Cube, that's right. Robert Feigenberg, and he'll be presenting on their approach to getting small satellites into orbit in an affordable and repeatable way. Any minute after.
You're right. I'm coming to you from Washington, D.C. Excellent. Thank you, Jim. Well, good afternoon, everyone. It's nighttime here in Washington, D.C., so I think we have a good set of presentations so far. We'll talk a little bit about our launch system. It's a Swiss company, obviously. We are based in our headquarters in Switzerland, Bayern, a small town in Switzerland. Our company basically was founded in 2012. That's when it was released to the open market. We are privatizing the heritage of a previous program, which was called Hermes, and Hermes was the previous space shuttle European program, including ESA, was undertaking at the same time as the U.S. space shuttle was taking place. So our vision is to offer a flexible, recurrent, and affordable access to space, with the objective of ourselves to integrating, developing, and manufacturing all the subsystems to operate a a fleet of suborbital reusable spaceplanes to launch small satellites up to 250 kilograms, which happens to be the fastest growing category of small satellites today in the world. So our system is also being designed today to be evolvable such that it will allow us to pioneer the future of high-speed suborbital human transportation, point to point. Not tourism flights, but actual transportation from continent to continent. So today, 70 employees with 200 engineers are working on this project all together between Europe and the United States. Here we go. The cornerstones of the company are obviously to be an affordable system. That's what we're trying to break the mold on right now, is to make it affordable, to have access to space for an increasingly larger amount of customers, and particularly with the smaller satellites, so they don't have to be always ride sharing, but actually be primary customers and allow it to be launched into space at a much smaller cost. Being a flexible system, we can launch from multiple locations and multiple airports. The responsiveness in the sense that we have a very minimal upkeep to be able to prepare for another mission. And then recurrence is important for us too, because that's another thing that's important today, is to be able to have frequent access and recurrent access to space, with the goal of being an operation responsible and low-cost launch. So our solution is the SOAR reusable launch system, and it's basically an integration of components that are already at very, very high technology level today. We're bringing them together and staging them in an optimal way such that we can reduce the operational costs for maximum reusability, right? If you look at the part on the left-hand side, the traditional launch vehicle, in this case a three-stage launch vehicle, every single stage in that vehicle is not reusable. On the right hand of the screen, you're looking at our vehicle, which is the SOAR system, where basically the first stage is an aircraft, a large body aircraft, which obviously comes back and lands at the point of departure. The second stage is our SOAR shuttle, which is also a reusable vehicle, and the shuttle then goes up and releases the third stage, which in itself is expendable. That's the only part that we do not bring back. We actually do a retro burn such that it comes in and then disintegrates after it completes its mission. So by maintaining the first and second stages of total reusability, we're able to offer very, very competitive pricing on the actual missions themselves, access to space. So the third stage dispenser, or the third stage of our system, is actually the dispensing module, which has a cage itself, a structure with the propulsion, avionics capabilities, such that with multiple firing, of course, and you can reposition at different planes and different locations for during the same mission. In the front of the dispenser on the right-hand side, the right bottom side, we have a primary mission customer. In this case, it could be a 50 kilogram or 250 kilogram customer. And then once that customer is released, then we have the rails, the secondary dispensers, which we could outfit depending on the types of CubeSats that we have in there. We can outfit up to 26 CubeSats for the same mission. So in one mission, we could release a primary customer and up to 26 CubeSats as well. The flight operational model for the SOAR system, I mentioned before, the aircraft takes off, approaches the 10 kilometer or 33 feet flight zone. There it separates from the SOAR shuttle. The SOAR shuttle then goes up all the way up to somewhere between 80 to 100 kilometers, depending on the mission. And at that stage, it releases the third stage from its cargo bay, which then can eject a satellite all the way up to 700 kilometers sun-synchronous orbits. So that's our capability today for maximum payload capability. In the rollout of the business, however, we have this in three phases. The first phase is to operate the aircraft that is being modified already to carry the SOAR shuttle, but to operate this aircraft for the first 3 years as a zero-G flight vehicle, parabolic flight vehicle. And by doing that, we're getting experience in the company, manage infrastructure, operations, and by the way, also creating some significant revenue for the company over 3 years of service. The second part of the business is to operate and launch a satellite, which is our core bread and butter for the company. And this would be happening from 2018 onwards. And then, in the third stage, and only after we've been successful with the commercial satellite deliveries, will we then put in a pressurized manned cargo module in the cargo way of the source shuttle, and this would be for high-speed travel, human travel, obviously. But all phases are generating operational revenues, and that's the key for us because we have near-term revenues 15, the core of our bread and butter in 2018, and somewhere in the 20s, and only then will we start performing high-speed travel for human transport. In the company, we have an all-star cast of partners, including Dassault Aviation, Sonaca from Belgium, Elecnor, Meggitt, Thomas Alenia, which would also be the manufacturer of the pressurized compartment for human transport, Russian rockets from Kuznetsov, Moog from the United States, and so forth. And as technical advisors, we do have ESA, EPFL, and so forth. And our main sponsor for the tail of the vehicles is Breitling worldwide. And Breitling has now released a zero-G watch, which is exclusive for those customers to fly on our zero-gravity aircraft only. You can't buy it on the market. So a couple of activity updates, just to keep you abreast of what we've been doing the last year or so. In November, or actually last year, we announced in June the advent of some drop test activities in preparation for release of a vehicle in Canada to test on the avionics, and we did that in October. We did avionics, telemetry, communications equipment. We flew all mission profiles that we were going to be performing, and in expectation of having this performed in the reduced scale shuttle glider, which will be later on this year. And at that point, we shall actually release the vehicle from 12,100 feet, have a flyback of its own avionics, and that mechanism you see there on the bottom right is the fin and the jig mechanism that we've already flown this past campaign, and we'll be then releasing a small shuttle and actually come and see it to fly back to the airport. Yes. Other activities for 2015 are the fabrication of a 144 scale sword test rifle, which is completed now, and we'll be putting that through the Mach 0.8 to 2.8 tests with a PDR accompanying schedule for mid-2015. So very, very much on track on the program for the shuttle. I mentioned to you earlier that we have a zero-G campaign, which Breitling is sponsoring for us as well. This is with our first aircraft, and this begins in 2015. We're performing parabolic flights with the largest aircraft in the world performing these sort of activities. And this will be flown actually with our dedicated 12 crew members. There you see everyone lying down on the floor. As you're going up on the parabola, 1.8 G's experience, and after reaching the apex of the parabola, then you start coming down, and then everyone's floating in free fall in the aircraft. And we'll be doing this basically for tourism, but also, as I mentioned before, for the experience of having to actually perform these missions around the world. So, what an added value of this aircraft also is in the belly of the aircraft, you'll actually have these small containers that are small racks that are going in a pressurized container. And this container will be exclusively for research and for the science markets, and we'll be including also not only power and the telemetry for this, but also a two-way interactivity, so you can actually interact with your experiments as they're flying through the problem. So that's an important aspect of the vehicle itself. We're beginning our itinerary in the second semester of 2015, and as you see there on the map, we'll be doing a worldwide campaign of zero-gravity flights for the first 3 years of our company. So with that, I know we have a short time, and within my 10 minutes, I thank you all for listening, and I'm open to any questions you may have. Thank you.
Yeah, we have questions if you're attending. Sorry, what was that?
What's the qualification required to fly the core shuttle?
So the question was, what is the qualification required to fly the solar shuttle?
Well, the solar shuttle itself, as I mentioned, is designed to launch satellites. So where our customers will be those companies that are the need to place in orbit certain of their payloads, in this case, multiple satellites into space. For flying the shuttle itself, as a human. This would be in the 20s, and for this you would have to. We don't want everyone to train to be an astronaut, obviously. So you wouldn't fly the vehicle at Mach 10, which is its rated speed. For delivering satellites, we'd actually fly at Mach 3.5. And by flying at 3.5 Mach, we're able to not have every customer be an astronaut and be able to tolerate 3-4 hour flights from one continent to another. And that's our ultimate goal, is to be able to do an hour-and-a-half flight to Paris from New York, for example, or from New York to Japan, and then for 3 hours. After that, you wouldn't have to train to be an astronaut.
So how to join the program to be a shuttle pilot?
Al, what do you expect what we'd like to know how to join a shuttle pilot?
Well, remember this is the shuttle is unmanned for the satellite version. For the manned version, obviously, we would have a pilot and a co-pilot. It wouldn't be very much because the vehicle is very autonomous, but it would be there for more than anything for security. So a shuttle pilot would be obviously there are employees of the company and people that are highly trained to be able to prepare for different mission abnormalities. So to apply in the company, at some point we might need several shuttle pilots, but at this stage we're having one. So we have those shuttles already here.
Few more questions.
Yes.
I wanted to find out, following on from that comment of the type of flights. So obviously, I would assume you're going to need special airport landing facilities that may actually on bus site and have the problem of landing, say, Australia, with the facility that would take off the airport to transport your people back to your own facilities, if that's business. So what are you looking at in terms of requirements for airports and pre-launching from another place that's over the road?
Okay, but that's a valid question. And in fact, what we need is a simple 10,000 foot runway for the vehicle. That's basically the limiting factor here is the aircraft itself. A large body Airbus requires 10,000 feet for landing and takeoff. The shuttle itself can do less than that. It's a small vehicle, 36 tons. But by the time we're flying vehicles for human transport, our idea is that we would have several shuttles and we would then be flying back and forth between point A and point B. So we would start with one itinerary of high value customers, expanding to 2 and 3, and for that we would have multiple shuttles that would actually be flown back and forth with the aircraft.
Okay, and last question.
Yeah, hi Robert. You talked a lot about the ability to launch more spacecraft as well as people, and there's a lot of competitors like X-Core, Generation Orbit, Rocket Labs, and we've heard all about those. So would you characterize your company more interested in human spaceflight than in throwing up bits of electronics? What's your thoughts on that?
Well, not really. I mean, the bread and butter, of course, for us, and the biggest part of the business plan hinges upon the launch of satellites, and that's a core requisite. And we believe that has a large future, and this is the one we're all preparing for. The multiple companies you mentioned are all preparing for that sort of growing marketplace. The fact that our ultimate objective is to use the same vehicle without any modifications or minor modifications to be able to then transport humans is our ultimate vision, ultimate objective. Just like everyone has, Elon Musk wants to go to Mars, for example. We want to start trying to have an influence in transforming the way people travel eventually. But our bread and butter, our core business is indeed launch of satellites.
Well, thank you, Robert, for your time and joining us from all the way across the States. We'll let you go and move on to the next presentation.
Thank you very much.
Our next presenter is Robert Brand from Project Construct. We'll be talking about again critical technology.
Thank you. Look, this question, who's heard of this thunderstruck? Ah, okay. At least the basically, this is part of getting up and going in spite of the fact that we don't have a space agency. It's one of those projects that's just on the way. We have a core group of space crazy people, in a good way, that want to go ahead and just move on despite not having any support from the government. There's a hole in the system that we feel we can fill, and that's basically being a space courier service. And the interesting part from a CubeSat point of view is if you're taking something somewhere, you're returning with an empty payload or vice versa. So if we're actually going to collect something from space and bring it back to Earth, we'll end up having space for CubeSats along the way. But let's have a look at Thunderstruck and where it's at, because it is early days. Basically, it's Lego style construction. We're looking to get into orbit in 5 to 6 years, so we have a long way to go, but we are surprisingly a long way towards that goal, so it may actually move forward. Basically, it's not just a straight single craft, it's a series of craft. Winged re-entry vehicle, which actually we're working on testing some of the capabilities. We've got a drop test coming shortly this year. And there's also a capsule version, and there's a version that just won't come back. So basically, we can fulfill any sort of need that a spacecraft might have, provided it's in the lower range. So if it's coming back with winged or capsule versions, we'll be looking at about a 50 kilo payload. If we're not coming back, we can probably carry more like a 200 kilogram payload. But there's a lot of people in that space, so we're not necessarily thinking that's going to be a fabulous area for income production for us. We started off by having a look at trying to produce a test phase, basically to look at stability. So we've actually taken out all the lift from the vehicle. And we had a fairly wide body because that's what we're going to use when we go to a spacecraft version, but certainly that will not be the shape of our re-entry vehicle. It'll be more like something more like Dream Chaser, a very small version of that, or similar to what the S3 presentation showed. But it'll be the smallest winged vehicle that can actually get stably through from low Earth orbit to stably getting on the ground and not burning up. Things become more difficult once you have a small aircraft. Small areas of change can create great areas of drag on a small craft and make it very difficult to control. So when we started doing the test, because we wanted this thing to get to Mach 1.5 to actually test our ability to actually break it, and to make it stable. And we found that when we did all the work on the laptop simulations and everything else, that it had to be much thinner to ensure that we could reach Mach 1.5 for the test in September this year, which will be up at long reach. So that's going to be quite interesting. And because we're going to break so many world records with this little machine, we're going to be, I think it's one of the TV stations that's committed to going up and covering it, a bit like they covered the Red Bull Stratus jump. So we may get something like that going in this country just for this sort of flight. So this thing's going to be about 3.5 meters long for this test. And it's not testing the aircraft design, it's testing all of the systems, in-flight systems that we'll be using in about 2 years' time to put this thing on top of a sounding rocket. And as I said, it won't look anything like this. But when you want to take out all of the lift and all of the inhibiting factors for going supersonic, you have to come up with a design that's going to work. We can actually drop this thing from 40 kilometres and still go supersonic quite happily for a long enough time that we can do the test we require. So So that is a video that was showing some of the systems that we've used. So for instance, that's just looking at one instant in time. There are different pressure levels starting from the lowest to the lowest pressures to the greatest pressures. And we found that our nose cone actually was the inhibiting factor, the size of it, the actual angle of the pointy end of the cone and everything, so we had to change that. And it was very interesting to see how we designed this thing for return to Earth. We'll have to have some sort of blunt nose grab similar to the others. At least this is the evolution. So we're about 6 years out from actually having a vehicle drop back from orbit. The actual test coming up will land automatically. So these are the systems we will be testing for the return from orbit, return from sounding rocket test. So in about 2 years' time, we may actually have a commercial vehicle to go on top of the sounding rocket. Again, looking nothing like that. As I said, these are the transonic and supersonic tests that we'll be doing later in this year. So basically, we once committed, of course, the whole thing's automated to land. We can take control, but the systems won't let us exceed the limits of the craft. So the range of authority they have is actually the range of authority they're going to grant to us. It's the opposite way to most flight control systems. In very low aircraft, we'll be using GPS and we'll be using video flight control markers on the engine, all the usual stuff. So this is a solid vehicle that will undergo a lot of testing, drop tests to be done once we have the full re-entry vehicle. So basically, as I said, it's plug and play. So one of the greatest areas of income for this is actually in asteroid mining, which has been slow to take off, but luckily we've only just started. So by the time they're ready, we should be able to have a vehicle ready that can go out, collect samples from a survey vehicle, and come back. So we'll give them a payload container, I'll fill it up, and we'll swap out the empty for the full and come back and land with the samples. That allows the mining companies to actually keep their vehicles out there surveying the next asteroid and the next asteroid. But it does give us an interesting opportunity because we have a payload on the way out, the full one coming back. So we can take out a range of CubeSats and the like to areas that are not normally being visited by CubeSats. And that's going to be where things do change very dramatically. We'll be able to stay in situ for a period of time and be the relay vessel, communications-wise, for the communications back to Earth, or two-way communications for that matter. So we're looking at opportunities to take CubeSats out as far as the asteroids in Earth orbit. And potentially, we are looking at the opportunity with one of our providers of the ion engine technology who's interested in doing a shakedown flight to Mars. And that seems very ambitious to me, but everyone tells me in the group that this is definitely something that we can do very, very effectively. It's going to take a lot of work, it's going to take a lot of professionals and a lot of money, but this will get there. The money is basically assured already. It's private investment, and I'll be able to announce more on that in the next 12 months. All we can do is point-drop analysis at the moment. It means we can do it. We don't have to find detail to actually give you the full orbital information that is possible to get to Mars, but we're all in the area that says that's fine. It will take us about 2 years to get out there with an ion engine. We don't intend coming back, so we wouldn't take a wind vehicle out, we wouldn't take a capture vehicle out, it's just going to sit out there. And we're expecting it to be in a very high elliptical orbit, so that any experiments that are going to be done can have a good range of areas that they can look at in the experiments rather than just staying close or staying out a long way. And that's actually quite easy for us to get into that very elliptical orbit compared to, say, the low orbit. So that's something that I think is going to be fairly important. And also, because it's going to take a couple of years to get out there, it gives us lots of launch opportunities during 2022. That means we're not restricted to very precise timings and so on as far as launch windows are concerned, as we might have with a chemical unit. So we need to stay in close. We will stay very, I don't know what distance, we'll have to work with the CubeSat operators so we know what distance. We don't want to collide with them at the same time when we're going around, but we need to stay close enough that we can be the communications link back to Earth. We're working on a project to have old dishes around the world be refitted for communications, space communications, those with a small enough aperture as far as the angle is concerned. Some of the very older spacecraft had very tiny apertures rather than 5 degrees that the more modern ones have. And we should be able to stay in good communications with it. So we're looking to not only provide the craft, but the communications links and the mission control. So we're actually intending for companies to be a total solution once we're not building rockets. But the opportunity is there for it to be a one-stop shop for a service rather than a sale. And that means we can help with the whole communications with the CubeSats ourselves, not just hand it over to a communications company. And we expect to stay in orbit around Mars for about 1 month. Now, this is probably about a 50-50 opportunity on the Mars side of things. Few contracts have to be signed yet, but it appears to be in good standing. Definitely, we want to go out to the asteroid. That's part of the operation. The asteroids in Earth orbit. It's part of the operation because that's really the money. That's it. Thank you.
I encourage you to all ask questions during lunchtime. Robert about the project Understruck, and we'll move on to our next presentation, which is from Modular Systems. And we've got Brandon Million online to talk us through the Neptune 5 launcher. This was mentioned briefly in one of the previous presentations in the summary of up-and-coming launch vehicles and small satellites.
I can hear you. Can you hear me? Okay. Greetings from Mojave. Thanks a lot for giving me an opportunity to share a little bit about interorbital systems. It's a company that was founded by my husband and myself in 1995 at the Mojave Air and Spaceport, where we have manufacturing and rocket engine test sites. We have launch locations worldwide and are expanding those as we speak. Our Mojave location is dedicated to prototyping and testing of components for our orbital vehicles. We have also a private launch area where we can conduct low-altitude test launches, which is most convenient and very rare in the world. Most of our activities are going to be taking place on the ocean in what we call a mobile self-contained spaceport. We haul the rocket out to a location for which we have a license at a particular latitude or longitude, and this can be changed depending on customer needs. But this gives us a great deal of flexibility and what we like to call launch on demand. We don't have to wait in a huge spaceport line or pay those exorbitant fees, so we can pass those savings on to our customers and have just recently acquired our staging area in the Port of Los Angeles. So we're preparing for some test flights this summer that will test the ocean launch system. The core of our Neptune series rockets, or our N series rockets, are the common propulsion modules, or CPMs as we call them. They're straightforward sounding rockets. Each CPM has an engine, a valve section, fuel and oxidizer tanks, fairing, and a brake, we like to say. So these are very simple units. And as I mentioned, they can be used as standalone sounding rockets. We have a launch of one to a space altitude coming up this summer. The SR-145, which carries 145 kilos to a 310 kilometer apogee. So it's a great testing opportunity for a lot of people who are flying on our orbital launches to test their systems. And there are a number of openings on that launch. In case anybody's interested, please contact me. We manufacture and test all our rocket engines. For engines and thrusters, that is. There's a photo of a thruster being tested at the spaceport. These are run on a storable mixture of nitric acid, this high-density nitric acid, and purple alcohol, and turpentine. So we're really the first in the U.S. to use that combination, but it works beautifully. No combustion instability, so we're very happy with it. Also, it's a substitute for the expensive and toxic hypergols that, like hydrazine and nitrogen tetroxide. And we get hypergolic ignition with these propellants without the dangers or vast expense of these, I guess, common dangers hypergolics would bring with them. And I always like to stress that we make all our engines in Mojave. They're made in-house, they're designed and manufactured there, so we don't rely on Russian engines. This is a test run of the workhorse for all our propulsion modules, the general purpose rocket engine, 7,500 pound thrust, nitric acid, turpentine, ablative engine. It's our main engine, and that's a 24-foot long flame that you see there at, again, at the Mojave Air and Spaceport, and we're at Test Site 2. So we designed this whole system for ease of use, no cryogenic infrastructure, all composite construction for the engines. We have replaceable plug-and-play chambers, as we call them, for the engines if we wish to reuse them. And it's really designed for rapid mass production. Here's a photo of preparations for our first test launch. And this single unit, this CPM, or in this case the CPM-TV, Common Propulsion Module Test Vehicle, is the exact size that the bundles of rockets will be made of. We'll take a minimum of 5 of these rockets, and combined they give us what will be our minimum bundle of that will give us orbital performance. So this particular test, this flight test, carried 2 CubeSats and 2 TubeSats on board and tested a number of systems. It was a fantastic thrill to see it lift off. It's a half a ton, and within 5 seconds it was going Mach 1.5, so it's really a thrill. And we recovered the rocket, and all 4 payloads, which were intact and still functioning. And we're refurbishing this particular rocket to use on another low-altitude test flight for a guidance test. Shot from above there on Rocket TV. And that launch really started our commercial launch services. So we are now operational for sounding rocket services, both from land and soon to be from the ocean. It looks like it's going to be around June that we we'll have all our permissions in place to do our first ocean-based launch. The payloads on that particular launch were varied, and most were flying with us on the first orbital launch. National Cheng Kung University had 2U on board, and Boreal Space with a Brazilian partner, 1U CubeSat. And our Google and their XPRIZE team, Synergy Moon, had a communications payload on board. And then the most notorious, I like to say, is John Frusciante's from the Red Hot Chili Peppers enclosure project. That turned into a fantastic advertising campaign that ended up winning the Golden Lion Award at Cannes last year. So pretty wild and varied crew of payloads on that. Primary hardware was tested. We tested the propulsion system in flight, cable launch device, and our pyrotechnic staging system, which will be used on our orbital vehicle. We had our AST and FAA people out there to witness that technology demonstration, and that worked perfectly. Our current launch manifest has 90 plus CubeSats and CubeSats on it from more than 15 countries at this point, and we're rapidly closing on our 100th addition to that manifest. So things are going well with us. We're selling our personal satellite kits as well, so many of those 90 plus satellites are made of our kits. And also on that manifest is our launch with Synergy Moon at the end of 2016. We compete in the Lunar X Prize. And we're booking now for lunar sample return surface missions, and eventually for lunar tourism. This is a rendering of our N5, or Neptune 5. It's a 3-stage rocket. The 4 outer modules are the first or booster stage. The central core is second stage, and that small item up at the right there is the satellite deployment module. So it's a simple combination of our, what we like to call our off-the-shelf modules that we can turn into really a vehicle that is custom for any mission. That can go from the 5 modules through the 36 modules, as you see in this notional rendering of our lunar rocket. So this is all leading to manned flights, lunar missions, and interplanetary missions, all using those same basic modules. We're working on our lunar landing system that also serves as a test for our guidance system. We call it Virus 1. You'll see when it has its lights on as well. We'll see why we call it that, but it's a friendly virus. It's a great test bed for the types of things we have to do before we put that system on rocket for the summer's launch. We have, as I mentioned, lunar sample return missions that are coming up after the Google Lunar X Prize, and we'll make those samples available to collectors and researchers. The hardware development sort of overview here: our modular, orbital, and lunar launch vehicles, orbital spacecraft, a wide variety of those, lunar spacecraft, and satellite kits. And launch sales here really drive our program. We're pretty much self-funded, and the pre-sales of launches, our advertising, I guess in some cases they would be called stunts, but it's called our programs, are really a fantastic stream of revenue for the company. And as I mentioned, the personal satellites have everything in there that you need to make your own satellite. And if you're an academic institution, you can buy a CubeSat. You see that cylindrical form factor there for $8,000 US, and that includes a kit and a launch. There's a partial manifest of CubeSats. Again, everybody from Rochester Space Lion from Sweden through NASA, through Vietnamese and Saudi Arabian universities. Fantastic work. Many more CubeSats, And among these are art projects, music projects, pure science projects, citizen science projects, and again, from a huge variety of countries and a wide variety of experiments and more there. And also on board is are some satellites from the University of Sydney, which may be upgraded to CubeSats, I understand, shortly. So that for us is exciting, and the more countries we can assist with our launches, the better that is for us. And like to close out the presentation, just some photos of various groups who are using our satellites. There are children in Brazil who are 11 years old who are building them, and all the way up through the Naval Postgraduate School and NASA, as I mentioned. And it's just a huge variety. So we're very, very near to our first orbital launch. We have the 2 test launches this summer, followed by that orbital launch, and it's an exciting time for us. And we intend to be the lowest cost launch vehicles in the world, with the real launch on demand available for our customers. So thank you.
We have time for a couple of questions from the audience about orbital systems. Yes. Hi, Rhonda. Can you hear me? Yes. Hey, Rhonda. Can you hear me? No.
Okay. Yes, I can. Can you hear me?
Yeah. I saw one of your slides. You're using a composite combustion chamber in novel.
Yes.
Is this for the first stage? Could you comment on the development of that, and maybe quantify some of the performance increases you get?
Yeah, it's actually for every one of the modules, for every one of the CPMs will have its own, and it's ablative. It's pretty ancient rocket technology, but it gives us a high-tech performance. We are very much into using modern composite materials, but using that rather old method of dissipating heat. And it works very much like, say, the heat shield on say, Russian Soyuz. It's extremely effective, and we can conduct very, very long burns using that method.
And one more question.
Yes?
Hello? I just wanted to ask you, you pointed out that your film materials are not toxic, basically, and also the comment about the Russian engines. So, two-part questions. Russian engines, obviously, are you getting any support from the US government because of what's happening with Ukraine, obviously, and the situation? And also, to the other side, are you getting any support in terms of rebates or credits because you can be using non-toxic materials as opposed to toxic?
Actually, none of the above. We're operating completely independently, and we're generating our own funding. We did have an asset contract that was really for data on the flights, but this rocket has been in development for about a decade, and the propulsion system even longer than that. So we started originally using liquid oxygen and methanol, and as we began to scale up, saw that it would, for us, be prohibitively expensive to haul around this giant cryogenic infrastructure. So we looked for a better solution, and we found it in storable propellants and high density propellants. For us, it's proven to be perfect performance. So there's once we moved to the storables, it was just a straight ahead kind of a path. There was no question that would be what we'd use. And that incidentally was Werner von Braun's choice of oxidizer for his deep space missions. So it's not an unusual choice.
Okay, well, thank you once again for making yourself available and presenting today on this topic. And on that, we will have to move on to our next presenter. Thank you.
Hey.
Our next presenter is John Moody from Spaceport Australia, based out of Newspace, talking about winged launch vehicles and future opportunities in spaceplanes in general. Fantastic.
Right, how you doing? My name is John Moody from Spaceport Australia. It's an Australian, you probably heard about that and maybe haven't. A little bit of a rundown on that is basically the last 30 years I've been reading newspapers about all these people inventing space developments, etc. in Australia. And all these new developments, there's no place to launch the actual satellites and rockets from. So what happens is that it eventually goes overseas, and some American company or European company grabs it and takes the product and investment leaves Australia. My proposal is basically to get a spaceport built, just a military-sized runway. We're looking at about 9,000 metre runway, 9,000 foot runway up in Northampton. I've currently been talking to the Australian government and the Queensland government in regards to getting some backing on that venture. We just come back from the States for a speaking to Andrew Nelson and S3, which is out here, which is Joy, and the Express operating in Australia. I got the idea for Rockhampton from Andrew Nelson, who was the ex-president of Export Aerospace, and it was his suggestion that he suggested Rockhampton. I was originally looking at Brisbane there, and worked out to be, I just couldn't get any movement there. Of course, there were people who wanted to talk to me, so we ended up having a look at Rockhampton, and he suggested that it was easy to actually get to the International Space Station from Rockhampton than what it is to get to from Moora. So I guess I took that into consideration, and that's where I'm at, I guess. I'm trying to bring all these companies and these ideas together and try and make something for Australia rather than the business leave Australia. That's what I'm trying to do. In the process of that, my vision is space planes, really. I'm not really with the rocket thing, so what you see out there is what Richard just showed us before. And that's the S3, where you've got you've got the Boeing, as you see, you've got the launch post, boost, upper stage position, and delivery of 700 Ks. Now, you still have that, but in Australia at the moment, we don't have any way of getting that up there, or anywhere to lead from. So, as I said, my thing is space planes, not rockets. So I just can't see this happening until we get someplace for Australia to have as a base of operations. And that's basically where I'm coming from. That's about it. Now, I've just got a few little photos I'll show you here. Okay, so you've all seen the space planes. I'm sure you've seen the S3 before. This is the SOAR space plane from Swiss Space Expeditions. And you'll see there, you've just probably seen it before with Richard's rundown on it, but the top of the base is the top of the space plane opens and deposits, etc. Satellites or persons or
Scans of Red Bulls.
Yeah. Okay, so you saw the nano satellite there, which is the dispenser. You saw on the tip of it, which is the 200 kg satellite. Down the side of that is probably, which Richard didn't explain very well, is where the nano satellites go. So you've got the top of it here, which is the optic satellite. That bounces off, separates from the orbit, and then under the optic satellite here, you'll find about 24 nano satellites. So they're released once the optic satellites are released, and there's around about 24 altogether hiding behind that optic satellite. There's various companies doing it. I mean, Virgin Galactic are another space plane company that is looking to do the exact same thing here that S3 is doing. So there's about 3 major companies at the moment starting to come forward. Export is one of those companies as well, but Export probably doesn't do same sort of size satellites. It's a little bit smaller in what it does. So if you want the big optic satellite, this is probably the better way to go, I think, at the moment. So there we've got Export. So if you have a look at Export, which is Link's space plane, you'll see that on the top of the vehicle is actually where the payload B will go. So this will go up to 100 kilometres, and yeah, that'll jettison at 100 kilometres, and it'll carry on to its low Earth orbit. Now, what you can put in there is it's probably up to you. As you can see, everybody's here making nanosatellites and got one to launch already. So I guess what we're trying to do is get this in Australia. So we're trying to get the S3 systems and the Lynx systems over here in Australia, obviously without spending a lot of money, and currently negotiations with Lynx and S3 to do that. Probably where we're going to start off really is in the zero-G flights. That's probably the safest place, I think, for us to start with. We've currently started talking to CASA about having zero-G flights in Australia. They've been very helpful with us. We're going to approval stage now with that. So we're looking to do those flights around about 2016, zero-G flights. And we're looking at having turn the first sort of stone on Australian satellite launches around about 2018. So that's what we'd like to do. Any questions so far? Yeah.
Yeah. So you've got the space plane on there, but with the spaceport you're looking to develop in Rockhampton, are you actually going to try and accommodate rockets and stuff as well?
At the moment, we're looking to accommodate just so just the space planes at the moment. Because we've got to move it. Like the whole idea is to be able to use an airport. So it's just basically tapping on the existing infrastructure of the airport. So that's exactly what we're doing. So instead of going up to 40,000 feet, 5,000 feet, we're going to 100. This will answer that. There's a little NA satellite there. I thought it was where the Cubes balloon drop off. And I think it's around about 160,000 feet. That's also something that you may not have seen. That's the current ESA space plane they've got in production at the moment. It's unmanned, but it'll be operational hopefully probably sometime in the next year, we think. And that's a little bit of a size-wise to compared with human figure compared to the spaceship itself. It's around about 5 feet high, 17 feet long. And again, I said that's just total machine that you're looking at. That's pretty much my show. I mean, yeah, that's pretty much my scenario where I'm coming from. Anyone else want to ask any questions?
What's the status of getting the spaceport up and running? What's the status of contracts? What's the status of what it's going to be?
It's not. It's the status where it's at the moment. Is really talking about. I'm trying to get something. I need to get government backing for it to make it happen. So, as I said, I read about these things in 1978, and then again in 1988, 1998, and 2008, but no one was doing anything about it. So just keep reading about all inventions, but nowhere in Australia to launch from.
Is it the regulation backing, or is it the funding backing?
It's our regulation backing.
There are obviously a lot of restrictions with getting international technologies to Australia, so particularly the US technology restrictions. So I'm wondering how this is more than on paper plan and aim to see the.
You said last minute.
I was just wondering how you see this as more than a plan that's on paper. How do you see space?
Well, I guess myself, I originally decided to get in the plane and go to the States and meet all these people who made such things. And that's exactly what I did. So November last year, I got in a plane, went over to the States and went to Mojave and met the players and the owners. And sat down and spoke to them and said, look, I'm from Australia. What can you do for us, really? It's pretty much where I came from. As far as regulation of getting American technology over here, I don't see a problem with it at the moment. The people we're talking to is Lynx Export and S3, and there's no issues there.
And last question.
So is this operating out of the domestic airport?
That's correct, yes. The whole idea is to operate out of normal conventional airports. Yes. So if you just CAS to regulate the airspace, etc. above that, that's kind of where I come from, sort of thing.
Okay. Now, I think we've hit our time. So we are now at the point where we can go and have lunch. You can approach any of the speakers and ask some questions. I encourage you to do that. We have 45 minutes for lunch. Now, lunch. It's outside on the green. Cheryl will lead the way and follow on that. Please take your stuff with you. This is not a secure room.